everyone, and welcome to the Responsible AI public session. I wish I could have been with you in New Delhi for what promises to be a very good session with my colleagues. Hello, everyone, and welcome. Hello, everyone, and welcome to the Responsible.
and specifically the Responsible AI Working Group session. I would like to welcome our moderator today, Sophie Falaha, Executive Director of the International Center of Expertise in Montreal for Artificial Intelligence. Thank you.
Good morning, everyone. So as introduced, my name is Sophie, and I will be your moderator for this session today. Perhaps starting with just a quick few words about CEMIA. As introduced, we are the International Center of Expertise in Montreal on AI. Basically, what we do is that we develop, we implement high-impact projects on responsible AI, and basically we support the experts of the GPAI into the development and implementation of their projects. As such, we support the Responsible AI Working Group, and it is my pleasure today to be moderating the session that will be doing an overview of all the work that was done throughout the year in the Responsible AI Working Group. So this should be a super exciting session, and I'm pleased to introduce you today, first the co-chairs of the Responsible AI Working Group that were not, could not join in person today, but who are joining remotely. So the co-chairs of the Responsible AI Working Group are Catherine Régis, professor of the Faculty of Law at the University of Montreal in Canada, as well as Professor Raja Shatila, Professor Emeritus on AI in Robotics and Ethics at Sorbonne University. And we also have today with us the co-chairs, the co-leads, sorry, of all the projects of the working group. So we have starting to the right-hand side for you of the stage, we have Michael O'Sullivan from University of Auckland. Then we have Juan David Gutierrez from the Universidad de los Andes. We as well have with us Amir Bani-Fatemi from AI Commons and XPRIZE. We are also pleased to be joined by Alistair Nutt from University of Victoria, Mr. Nicolas Miai from the Future Society, Professor Lee Tiedrich from Duke University as well. And we will also have joining online Professor Dino Przeski from University of Pisa, as well as Edithia Mohan from the National Standards Authority of Ireland, Benjamin Prudhomme from Mila, Paola Ricorte from University Technologico of Monterrey, and Francesca Rossi from IBM. So thank you very much, all of you, for the whole year, the hard work and all the effort that you put into the work. And what we now will do, I'll pass the ball to the co-chairs of the working group that will present the overview of the work that was done throughout the year, and then we'll pass the ball to the different project co-leads to do deep dives, I would say, quite quickly onto their projects, and we'll close the session by a Q&A that I'll have the pleasure of moderating. So that being said, without further ado, I would like to invite Raja and Catherine to take the floor for the introduction of the session. Thank you very much. And we have Raja joining online. Thank you.
Hello, everyone. Can you hear me? Yes, probably because I can hear myself. So I see the room is full. In fact, I'm very sorry to not be physically with you today. I'm sorry to miss this great event with you. Thank you for joining us anyway, and in the room and online. And I'm very pleased to present to you the progress of the working group, Responsible AI Working Group this year. I would like to first thank the summit organizers for providing us with the opportunity to engage with the international AI community and with the Indian community on our work that has been doing actually since 3 years now. And I would like to say also that this year marks the end of my mandate, both as expert and as co-chair of this group. When I stepped into the mandate of co-chair back in 2020, at the beginning of GPAI, our first objective was to select the priority themes we needed to address to tackle the challenges faced by our global society. This is now what we have developed after 3 years. Our project, for example, Responsible AI Strategy for the Environment, RAID, social media governance. We also also that these were the two projects we selected in the beginning. We created a subgroup also to tackle the challenge of the fight against the pandemic. Because, of course, as you know, we started while the pandemic was going on. And this was our project, Pandemic Resilience. These projects have explored complex issues, diverse and complex protocol issues, and are still running till today, and we will have presentations about these projects. Their work has been really foundational, central component to achieving our work in 2022. And we have also started working on new areas new actions in 2023, such as scaling responsible AI solutions, diversity and gender equality in AI, and our sandbox project for responsible AI government. These projects have been launched this year, as I said, and we were able to deliver practical outcomes that we presented as part of this summit as well. Unfortunately, my colleague Catherine was not able to join us, Catherine Regis, to join us live or online. But we have a brief note from her that will be broadcast soon now. So, Catherine, over to you.
Hello, everyone, and welcome to the Responsible AI Public Session. I wish I could have been with you in New Delhi for what promises to be a very good session with my colleagues from the working group present to showcase the amazing work we have achieved over the year. Like Aja, this summit marks the end of my mandate as the co-chair of the Responsible AI Working Group. When I started my mandate 2 years ago, I had 3 key objectives. First, to increase the connection between member states' priorities and GPAI's experts' work. Second, to further deploy a human rights agenda in our projects. And third, to include more gender and cultural diversity in our group and ensure that we have an inclusive approach in our discussions and projects. I'm happy that we were able to progress on all these objectives, and I hope that we will continue to do so in the future. It has been a real privilege to lead this working group of brilliant-minded people who sincerely care about the future of responsible AI. Our working group mandate closely aligns with GPAI's overall mission by contributing to the responsible development, use, and governance of AI systems, ensuring diversity and inclusivity to promote a resilient society which takes into account the interests of vulnerable and marginalized groups. Within our working group, we believe that to develop and use AI responsibly, we need to work towards technical, societal, institutional, and legal methods, as well as tools that provide concrete support to AI practitioners and deployers. We also need awareness and training to enable the participation of all and ensure the alignment of our systems with our society's principles, values, needs, and priorities. Human-centered approaches need to be at the heart of all decisions we make in the design and use of AI. And today, with the increasing influence advanced AI systems play within our societies, it is essential that an organization such as the Global Partnership on AI continues to deepen its work and brings both GPAI members, governments, and AI experts together to tackle the challenges of the future by providing a better understanding of advanced AI technologies and what safeguards must be put into place to guarantee safe and responsible use. I'm confident that our group will continue its progress in the next years as we have recently identified potential collaborative and high-impact projects emerging from the first GPAI Innovation Workshop, held in person in Montreal last September. We will also continue on various projects that will be presented today. I'm very proud of our work, and I want to say thank you to all the experts that give their time and expertise to ensure the success of this collaborative effort. So without further ado, I wish you all a great session, both in person and virtually. Thank you.
Let's move to the
Hello
next
everyone,
slide.
welcome to
Yes, thank you. So Catherine and I have been working together in the past 2 years, actually. I started my mandate with Joshua Benjo, and then Catherine Regis came in while Joshua has finished his own mandate. And we have working complementarity because Catherine has a legal and public policy expertise, and I have an engineering expertise. And this is a good fit for actually having the ability to understand all the facets, the complex facets of the work that we have been achieving in GPAI. And I really think that this combination of knowledge give us the required capacity. So the Responsible AI Working Group mandate is to foster and contribute to the responsible development, use, and governance of human-centered AI systems. And this in congruence with the United Nations Sustainable Development Goals, ensuring diversity and inclusivity to promote a resilient society, in particular in the interest of vulnerable and marginalized people. Next. Our group has 45 experts, including 2 observers, and these experts come from the members of the GPAI, which are shown on these slides, and the 2 observers are one from the OECD and a second from UNESCO. So we have also this international participation. Next. During this year, in 2023, we have produced 8 reports that you can find on the GPAI website. And these reports are the work of our groups, of our projects, and they will be detailed and presented by their colleagues, respectively. So, next slide. And I would like to now give back the floor. Our first project is about pandemic resilience. So, Sophie, back to you. And let me know if any thing is needed from me during this during presenting the project. Thank you.
Excellent. Thank you, Raja. I don't know. No.
Hello.
It's on. Thanks very much, Raja. So I would like to invite Mike to do the presentation on his project. You're more than welcome to join me on the podium.
Noarani mai ana o kutupuna ko Sullivan toku whānau ko te atu tokapori e noho ana o ki ngā whenua me ngā waitapu o te kauramaki. Tina kamihi, tina koto, ko makaho. My name is Michael Sullivan. My ancestry comes from Ireland and China. Sullivan is my last name. I live in Te Aratu, and I just want to acknowledge the mana whenua there, which is te kauramaki, and also welcome to all of you here. So I'm the co-leader of the Pandemic Resilience Project. Next slide, please. So this project started dealing with the global COVID pandemic, and one of the big issues with when complex situations like this occur is that governments are having to make decisions without necessarily knowing how those decisions are going to pan out. Alongside that, there's also the pandemic was happening in multiple different places, multiple different times, and so things that would happen, for instance, in New Zealand, in Aotearoa, New Zealand, versus things that happened in India were quite different, even if the decisions were the same. So because these crises were happening in similar ways in different places, there was a lot of noise being created in terms of decisions being made. In addition to that, some of the objectives of the governments throughout the world were the ideas of balancing, for example, economic effects versus the public health outcomes. And so the effect of decisions on those 2 objectives sometimes wasn't clear. What we did in the pandemic resilience is a solution that used data to drive those decisions, or at least inform those decisions. It enabled us to also generate scenarios, so try what if. So what happens if we put mask wearing on public transport, what happens if we close schools, what happens if we go to a full lockdown, and so on. Also, one of the things we found out during the Pandemic Resilience Project was don't put all your eggs in one basket is the best way I can describe it. That means use lots of different models, and there are lots of different models out there, and the Pandemic Resilience Project brought those models together in a way that we could actually benefit from all of those models in an ensemble way. And then one of the things I'm quite proud of is we had a very diverse group of people working on the project, both geographically diverse backgrounds, some gender diversity, probably not enough actually, so I have to talk to Catherine a little bit more about that. Also, the idea was to take skills that occurred in one location and be able to easily transport them across the world so that knowledge was shared amongst communities, and I think that's one of the keys of responsible AI best practice. Next slide, please. So this slightly complicated diagram is what was happening throughout the world. So I'm just going to wander over here beside people and forget my voice. So in New Zealand, so you can think of location A in New Zealand, we had estimates of global parameters. We had estimates of global parameters, we had estimates of what was happening in New Zealand, and we had some model-specific parameters. We created a model, we calibrated it to input data, we compared it to output data, we got a nice prediction, and then we calibrated that to work as well as we could. Other people were doing the same thing in other locations, Australia, the US, the UK, and so on. However, the global parameters across those locations weren't necessarily agreed upon. So the reproduction number, for instance, of the alpha variant of COVID may have been different in my model than it was in the models used in the US. So the idea was to make sure we're using parameters consistently, but also enable models that work well in one place to work well in another place. Next slide, please. So this gave rise to our ensemble of models. So you can see here we're using the same standard global parameters across both locations. We're also using both of our models in both locations and the same parameters at the location to run those models. We're putting input data in. Each of the models will allow slightly different parameters in the locations, but then down the bottom, a little bit behind our panel's heads, that's okay panel, don't worry, we can all see. Then we get the accuracy of the ensemble models, and again we're calibrating back, so we're now building models that are using the same parameters consistently. We have multiple models in all of our locations, and we've calibrated those models to try and discover the best parameters across all those models that enable the best fit to the data, so the best fit to the pandemic spread across all the locations that we have of interest. Next slide, please. What this meant was, now that we had multiple models in multiple locations, we could also use those models in a way where the best model for the best situation was selected. So in the plot you can see to the top right, there are two machine learning models, the conditional LSTM, I can tell you what LSTM is in a break, and the other LSTM, and then we sample from those randomly, and you can see the sample ensemble had a better fit to the data, so less mean average error than the two models by themselves, and this was because the conditional LSTM was very good for once the spread had died out, whereas the LSTM was really good when the spread was starting, and so if we could randomly choose between those two, actually we got a better fit overall. This meant using the models that we created, probably don't need to now actually. This meant now using the, oh, sorry, back to the previous slide. This meant using the models that we've created now, there's a lot of resilience, so we can use the right model at the right time. Within New Zealand, the data-driven models didn't work well because we didn't have a lot of pandemic spread, didn't have a lot of cases. In other places, such as the US and the UK, those models work really well. And so now this provides governments with multiple models. They can try and use the right model at the right time. We can weight the outcome of the ensemble depending on which phase of the disease we're in. It also meant that you could get insight from multiple models at the same time. So you didn't have to choose which model you believed. You could run all of them and see what they showed you, and actually you could adapt your decisions that would work well across all those models, so it would give you resiliency in decision making depending on these different types of knowledge. Because we standardized everything and used our models in multiple different locations, now we could really rapidly put them in place, various places. So for instance, in some of the testing we've been doing, we created a model that worked for both New Zealand and Sudan, and then pretty quickly we created a model that worked for New Zealand, Sweden, the UK and Kenya all at once. So we could really quickly put our models into new locations. And one of the interesting findings of this study was the ensemble model seemed like a good idea. The standardizing data seemed like a good idea, so why weren't people doing it? And actually I think that there's a lot of funding in various different locations really looks at creating one or two models, and the teams work separately and they compete a little bit even for funding. They come back and they provide the results. But actually, if we could work at ways of standardizing data, enabling situations where there's a interface, application programming interface from my coding background, where people could plug into the data, we get multiple models running in multiple places all at the same time, get the insights of these ensembles. Next slide, please. So we've got some key recommendations for policymakers in the report. I'm just going to summarise by saying what we think needs to happen is modelers need to work with policymakers. We need to embed the idea of modelling within our decision-making processes, but we need to make it easy so it can go lots of different places. However, we also need to make sure that those models are producing results that are useful in the real world. So you can see down the bottom, number 7, is looking at testing the readiness of the models in real life. So one of the things we want to do is what's called a tabletop simulation to try and see how would this work if a real pandemic breaks out. One more slide, please. So this is the last one. So where do we think this is useful for government? A lot of what-if simulations. So I saw this a lot within New Zealand. Tried lots of different things. See what happens if we put these interventions in place. We can also then move to the idea of, rather than predicting what's going to happen, we can start prescribing or suggesting what's going to happen. And so we can say, this is the level of your pandemic, so you should try putting these interventions in place, and that's going to get you your best health outcome or the best balance of health outcomes and economics. Finally, we can extend to other diseases, and really the key takeaway for me for this project is that the COVID-19 pandemic has shown how modelling can impact decision-making throughout the world, and I think the Pandemic Resilience Project has shown how this could be something that could be in place instead of the big scramble that happened to get models ready as the pandemic was progressing. Thank you.
Thanks very much, Mike. Thank you. Now I'd like to invite Amir as well as Francesca to present the project called Scaling Responsible AI Solutions. And Francesca is joining online.
Is Francesca with us?
Yes, I am. I'm here.
Wonderful. Thank you very much. Good morning, everyone. Thank you for being here. It's a pleasure to share with you the work of Scaling Responsible AI in 2023 as part of the Responsible AI Working Group. When Francesca and I started this project, the idea was to really put an attention emphasis on operationalizing effort around AI. There's a web of effort doing everywhere. People are working on policy, working on best practices, on benchmarking, on data governance, on funding startups, or doing basically Project AI for Good. But really there is a missing link in terms of understanding the levers of how AI can be operationalized and going from ethics principles that are governing us to some form of trustworthy, safe environment where we can actually scale applications and basically serve society. So this project was trying to sit in the middle of trying to understand what are the impediments, the difficulties of building responsible solutions and on how they could scale. Because at the end of the day, if you want to benefit people, the project needs to scale. They cannot be remaining in a lab or just a part of an article or a demonstration point. Next slide, please. So the project is really talking about providing advice and support and learn also, because we're learning a lot, from teams across the world that are building right now AI solutions that deem to be responsible, and help them evaluate how they can actually be set and be ready to scale those applications in a responsible manner, but also in a way to serve a much larger part of the population or different contexts or different areas. And of course, provide guidelines to AI teams, naturally, but also to policymakers on how to address issues and challenges that team faces, and how they can basically support scaling responsible AI solutions. Next slide. So if we want to summarize our work, it can be summarized in this diagram, which is there are many applications that would scale. For instance, a chatbot for customer support on a website can easily scale. You've seen many examples. Many of them are implemented today. We don't know to what extent they could be deemed responsible or safe for different groups of people. Or AI image generator may scale but may not be responsible. Adversely, there are solutions that are having been worked by academia and researchers that are meeting the goals of responsibility, but we don't know if they're going to scale. We don't know if they have access to a large pool of data to scale. We don't know if they're going to be meeting different regulatory pressures or governance structure. We don't know if they're going to be able to scale across different genders and contexts. So scaling becomes an issue. So there are basically 4 quadrants where some solutions could be neither scalable or responsible. Some of them are scalable but not necessarily responsible. Some of them are responsible and not scalable. The goal is to basically evaluate how solutions that are beneficial to society and could serve a large group of population can actually meet both goals. Next slide. So and I'm going to pass on to Francesca, my co-chair, to talk about it a little bit. We did a call for proposal and participation. We had 23 applications from this geographical representation, and we selected 5 teams from 5 continents to really work on these solutions. We could have selected more, but really the first year for us, the goal was to learn, understand the challenges they're facing, how they are understanding policy, how they understand regulations, how they understand data governance, and how they are tying it all together in terms of providing a readiness that we can evaluate thanks to our mentors and experts about their being able to scale. Next slide. I'll pass it to Francesca, my co-chair, to talk about a few slides. Are you ready, Francesca?
Yes, thank you, Amir. So, as Amir said, we had an open call where any team developing an AI solution could apply to participate in this project. And this was done during the first months of the year with significant outreach, because we really wanted everybody to know about this. And as Amir said, 23 teams responded from all over the world. And then we selected 5 that I will tell you more details about in a minute. And with these 5, we went through a journey from April to basically now that included many phases. So the first one was to really understand what their project was and what their challenges in terms of responsibility and scalability were. Then we matched them with some mentors, which were GPAI experts participating in the Responsible AI work group, but also experts from other working groups that were available to mentor and to help and advise these 5 teams in what their challenges were about and what they could do about that challenge. And I want to emphasize that not only we advised the team, but we also learned a lot from these teams and their challenges in really understanding what are the main issues in this path towards scalable and responsible AI solutions. So we went through a period of mentorship and then a period of evaluating what these teams were doing, how they had worked on their challenges, or they were planning to work on their challenges, and how they were planning to operationalize what we work together about addressing the challenges. And then for all this path, we wrote in the GPAI report that you can find in the GPAI website, we wrote our summary of what we learned and what we did together with these 5 teams, and also some useful recommendations gathered as inferred from the experience of this project for both AI teams and governments to facilitate the addressing of these challenges. To go to the next slide, here is just some key activities. I say the mentorship, the working on the challenge, the recommendations that we put together, the publication of the report, and then the evaluation of the teams on their implementation plan for what they have discussed with the mentors. And then the idea is to start again next year, but of course building and being much more accelerated, especially in the initial phases, because of the experience that we have been having this year. To go challenges, but also very different ways of addressing AI challenges and building AI solutions. So the team for India is about healthcare access, and it has challenges related to data collection and applications. The Italian team is about workers' well-being related to healthcare workers, and there we focus on the challenges for the use of wearables in healthcare and in industry in a very responsible way. The team for Mexico is about environment, and they were building a model, an AI model, to recognize deforestation areas in Mexico, and then support the government with decision support system that could help them make useful decisions from the output of the model. The team for Canada is about auditing AI systems, and in particular chatbots. And these the challenges that we focus here are how to build guidelines, for responsible AI guidelines for the analytics of these conversational systems. And finally, the team for Germany is building a platform for democratic participation, and is based on voice bots, this platform. And so here we focus on guidelines for the responsible use of this platform technology for the participation of citizens and, in fact, people-centered feedback. You go to the next slide. Some of the key findings. Although these 5 teams and projects were very different from each other and being done in a very different AI environments, we saw that they really faced some of the very similar challenges in integrating in the project what we would call responsible AI principles and scalable, so that they could scale responsibly. So here is a list of some of the challenges that we identified together with these teams. So to the human-centeredness concept, how you implement it in your project, how you embed it in a project. The data governance framework, the robust and transparent data governance framework, the consultation with stakeholders so that they can build trust between these users and the project. User education was a very topic that was talked about with many of the teams. And also how to adhere to the responsible AI principles, and through also the safe and effective testing of the projects. Also issues about safety while scaling a solution. And finally, there are some challenges that are about availability of resources before deployment. If you go to the next slide. So here is a very short summary. In the report you find a lot more details about the key recommendations that the project team, together with the mentors and the team and the 5 teams and so on, put together for 2 kinds of stakeholders. Both AI teams themselves, so these 5 but also many other AI teams, and also for policymakers, because some of these challenges can be, the addressing of these challenges can be facilitated by the governments. And also we wanted to address policymakers because after all, GPAI is a set of governments, so policymakers, that can play an important role in facilitating ways for addressing the challenges that AI teams face in making their project responsible. So you see, for example, for policymakers is focus on standards, on regulation, thinking also about competitiveness, about supporting infrastructures, about asking for controlled testing, of course, funding structure specifically for responsible AI, to not put speed over safety, but the opposite, to be innovative about evaluating AI solution, to facilitate data collection in a responsible way, public-private consultation, and so on. And for the AI teams, you see here also some of the things that are related to the challenges that I mentioned earlier, like stakeholder identification and consultation, responsibility as something that goes not just at the end of the project, but throughout the entire AI life cycle, impact assessment, being very clear about the indicators for responsible AI, again, testing in a controlled way, ethical oversight during testing, and decision-making, support for decision-making in human decision-making, data governance, and monitoring and evaluation. So you'll find a lot more information about each one of these recommendations in the GPAI report that we put together. If you go to the next slide, I'll pass it again to Amir to tell you more generally about what we learned and the next steps.
Thank you, Francesca. So as you've heard Francesca, going into the recommendations and specifically for AI teams and policymakers, there is so much more to learn. We will learn this based on not only the 5 projects, but also based on the experience that each mentor and each expert is bringing to the table, dealing and working with these teams. But also as we look at what is being done on the policy side, on the regulation side, on different academia. So the goal for us is to expand this work and to expand it in a way that we can capture more best practices from different regions, different countries, different sectors, different domains. So the learning can be shared accordingly. The hope is that the blueprint is a big term. I'm not sure this is the right term to use, but we're basically using the term blueprint in a sense that we want from GPAI to provide a form of a guideline in terms of how to operationalize responsible AI for different purposes. And this guide will include not only the recommendations, but the learning, but also data sets and different elements that could be useful across all stakeholders. We also want to increase the reach. Well, in 2023, we reach out to 15 countries through our natural connections. We hope that we can, thanks to more partners, reach out to many, many more regions and different teams to really be more inclusive and incorporate more learnings as well. But also to start thinking about capacity building, because many of these projects have to be taken care of and developed locally. Well, the learning could be general, and AI could be very generic in nature. Most of the implementations of responsible AI has to be in the context of its usage. And because of usage has also to be intertwined with policy and regulation and country and government support and community support. And they mean different things in different regions. So to go along those lines, we need to really be a little bit more open and try to reach out to more and collaborate more. We'd also like to collaborate with more governments because the incentives about promoting AI and safe AI should be aligned with responsible AI practices. So there is much to learn, but also much from us to also share in terms of our experience to different stakeholders, notably government stakeholders. We believe that the project could have some benefits, and one of them is a real actionable plans and basically some form of a life cycle of responsible AI. Everybody's working on those AI life cycles, but we think we can contribute on the responsible side. We mentioned the blueprint. The blueprint is going to be an important part coming from GPAI, both all the members and approved by all the members could have some value. And this is very complementary to all the work that standard bodies and governments are doing. But also, more importantly, many of these teams are struggling for funding, and funding in terms of resources, but also funding for scaling. So if there's a case to be made that certain teams and certain projects could actually be scalable, responsibly scalable, the case for funding becomes more obvious for them. So this is what we're trying to deliver that. Next slide, please. We're also looking for collaboration opportunities. We're talking right now, thanks to SIMIA, to a partner that will help us actually increase our reach to Africa, but also want to do it in more countries. The importance for us is that regional collaboration is critical, and what we've done demonstrated that there is really an exchange of knowledge and expertise between mentors and people that have been doing work on the academic side or industry side with NGOs and those who are working in the field. We want to provide more support to some of these teams. This support could be either cloud-based or database, but also knowledge support, which is the most important part. We're looking for more mentors and organizations to support teams, because if we have teams in different regions, naturally mentors that are going to be in those regions are going to be more involved and more in tune with their needs, the issues and the impact they could be making. Funding deployment, as mentioned, is important, so we're trying to think about how we can actually rally more funding sources to observe and evaluate how these teams and how these projects are moving forward. By being more inclusive, probably we can collectively increase the impact that we're making, be more diverse, and as Raja said at the beginning, we really want to work on AI for good for everyone, and extending geographically is very important across multiple activities. So we're going to be sharing more. There's a session after this session in room 16 where we're going to dive into those 5 projects, where more details about each team and more question and answers, and hopefully more a panel on discussing how we can go forward. But thank you very much again for your attention.
Thanks very much, Amir.
Thank you.
Actually, we'll take the questions at the end, just because we have a few other projects. But thanks very much, Amir, and Francesca as well. We're very much looking forward to the expansion of the project next year. Now I'd like to invite Benjamin Prudhomme to present the latest development of the Diversity and Gender Equality project. And Benjamin is joining us remotely.
Thank you, Sophie, and hi, everyone. First and foremost, I would like to acknowledge that although I'll be presenting alone, unfortunately, today, I'm co-leading this project with Paola Ricarte Cujano, who's Associate Professor at Tecnologico de Monterrey. And so the project is entitled Towards Real Gender, Diversity and Gender Equality in AI. And for your information, what we filed this year is an advancement report. So we're almost midway through the work of the project. And so we thought that today the most helpful approach to take in presenting the project was to talk a little bit more around the process, what has been achieved thus far, but also looking forward what we'll be hoping to achieve next year with most of the deliverables happening there. Next slide, please. Thank you. And so the overall objective of the report, when it was initially, of the project, sorry, when it was initially launched with GPAI, is to provide the AI ecosystem with frameworks, tools, and resources to incorporate DGE. So I'll use that term quite a bit today. Diversity and gender equality strategies throughout the AI lifecycle. And really the idea there was to kind of start from the premise, which has very much been confirmed in the literature review, that despite all of the advances and sincere work that's been ongoing towards diversity and inclusion in AI ecosystems, there's still significant gaps, both within ecosystems and also, of course, between ecosystems and countries. So this was hopefully a way of integrating applied research into this question to start mapping out a little bit more what we could do. And I emphasize on effective DG strategies. So the idea here is to really try and have measurements and metrics around what works, what doesn't, and so that stakeholders feel well equipped. So the first specific objective is to develop what we call a toolkit, or a public-facing resource to support stakeholders. So those stakeholders, that resource, the toolkit, will be divided between different stakeholders: academia, industry, policymakers and governments, etc., to identify the most useful and context-appropriate tools to enhance diversities within their own operations and within their own subfield in the AI ecosystem. The second objective, and I will talk a little bit more on this so that everybody has clarity and peace of mind, is to provide recommendations to GPAI to enhance diversity throughout its operations. And here the idea is that the report will be confidential and it will be only remitted to GPAI leadership. But as we are amassing that information and those voices around most effective practices for DGE, we had conversations with GPAI, which of course very much wants to continue upholding the best standards around DGE. And we thought that a good way of doing that is making sure that we mobilize that expertise that we're gaining now to advise GPAI in terms of different options or effective actions that could be taken to integrate better DGE considerations within the organization. So again, that report will be confidential, but those of you who are part of the GPAI leadership will be able to have it, and hopefully that's going to support the continued work, of GPAI around inclusion. And a few words on the approach we're taking. The first one is that we are approaching or framing the intersection of AI and diversity, gender equality as a matter of human rights. So we're looking at it throughout different resolutions, by example, from the UN Assembly, but also through the lens of different human rights like non-discrimination. All of which happens within a holistic approach, of course, because the project is global, but also with a very strong emphasis on intersectionality so that we make sure that we consider factors such as race, ethnicity, and disability, among others, and the way in which they interact. The second very important task that we gave ourselves was to document and build upon voices of marginalized groups, and we'll go through that later, but of course, it seemed quite obvious and important to us that any project around inclusion would first and foremost turn towards excluded groups and individuals to better understand their experiences as they try to navigate the ecosystem. And the last piece, and perhaps the most important one for many of you in the room, is to propose practical and actionable recommendations for effective changes towards DGE in AI ecosystems and for stakeholders specifically. So we can change the slide, please. Thank you. So as I said, in 2023, recently we filed an advancement report, which further documents what I'm going to talk about here briefly, which are the key activities that we've put together in 2023, which will feed in the deliverables that will come out in 2024. So the first one is literature review. And here it's a bit of in a way, a classic approach to scientific knowledge. So we've identified key themes, theories, methodologies, most importantly, the gaps in the literature on those topics to make sure that those gaps specifically we could integrate in the other ways in which we're collecting knowledge, like environmental scans and regional consultations. The second piece is the regional consultations. So we've engaged with localized expertise from 5 regions in the world, taking a multi-approach, so the multi-stakeholder approach. So the idea was to make sure that folks from industry, from marginalized groups, from government, etc., would come to these meetings and exchange about us confidentially, if they wish, of course, about the experiences, but also the best strategies that they found. So we've engaged in Latin America and the Caribbean, in Sub-Saharan Africa, in Middle East and North Africa, North America and Europe, and Asia and the Pacific. And obviously we've met hundreds of people in those contexts. And again, that's the piece where it's a very central piece to the project in the sense that it is very important throughout the project for us to make sure that we honor and build upon the voices that have been expressed there. Then we've incorporated community perspective. And so what we've done is once we've had a first draft of the report, we've identified community organizations to provide further feedback on the report so that they could share some practices or some comments on the practices we had identified. The fourth piece was that a part of the team was working on identifying the promising practices and resources. So to provide a curated and analyzed selection of them. And one of the issues that we've been hearing often for people who wanted to get involved in diversity and gender equality work was that there was a lot that was put out there, and it was very difficult for organizations to find focused material, but also material that had used metrics or that had a sense of measuring what worked and what was efficient. And so the idea there, as we're building this public-facing toolkit, is to make sure that we, as much as possible, create that one place where those stakeholders can go and feel comfortable and confident that the resources that they're using are both quite on point for their needs, but also have been tested or evaluated for performance. And the last piece is what we called an environmental scan, which was to map existing initiatives that aim to include DG in AI with the labeling and annotation so that people can not only refer to the toolkit of resources, but also to different projects and narratives that have worked globally. Next slide, please. Thank you. And lastly, for the outlook for 2024, so 2024 will will most certainly be a bigger year for us in the sense that all of our deliverables will be coming out. The first one is to compile and analyze the results of the 2023 activities. And there's a possibility there that we move forward with additional consultations as needed, particularly to fill some of the gaps that have emerged from the first consultations. The second is to develop and deploy the Diversity and Gender Equality Toolkit, which is, again, a curated and annotated repository of the most efficient tools that we've identified. And it would include explanations as to the advantages and the limitations of each of the tools that would be offered on it. And the third piece, there's actually another piece missing, sorry. So the third piece will be the delivery of the report itself, the GPAI report, which will include the recommendations for governments in terms of diversity and gender equality, specific to the context of the AI ecosystems and the AI lifecycle. And the last piece will be the confidential report, so the review and analysis of the current GPAI practices. And again, here the idea is really to be constructive as we want to collectively move forward towards greater inclusion at GPAI. And so thank you, of course. The last piece is of course to thank, as you can imagine, all of that work, and particularly the global consultations have involved an army of collaborators, contributors. And so I want to really sincerely thank the team that has worked there for their hard work. Direct you to the GPAI website if you have any kind of deeper questions or you're curious about the work that's upcoming. Some of that is in the advancement report. And the last piece is for those of you who might be interested in contributing either in expertise or throughout the consultations, or if you're just curious to learn more about the project. The project is under the management of GPAI's Montreal Support Center, CIMIA, so I invite you to communicate directly with them. Thank you.
Thanks very much, Ben, for joining remotely. So, as mentioned, any questions, feel free to reach out to us. The team will be there to support. I'd like now to invite our next speakers, with an S, Juan and Aditya, to present the outcomes from the Sandbox for Responsible AI Public Procurement Project. And a bit of timekeeping. I will ask actually all the next speakers to be efficient in terms of timekeeping and aiming at an 8-minute pitch.
Thanks, Sophie. So I'll start the timekeeping project. So this was a regulatory sandbox project. We started exploring the world of regulatory sandboxes. But what we found out was that the world of regulation itself is very nascent. Most jurisdictions are still thinking about regulation. EU is one of the first. Last night or the night before, they have kind of agreed on AI Act. So we gave it the direction of a sandbox project for public procurement, because procurement is one of the first questions on the mind of governments who are trying to procure AI products and services. Now, coming from government, I know how difficult, first of all, how laborious the procurement is in governments. We scanned some of the procurement practices, and that was the stage 1. Then we prepared a report which will be available to all the GPAI delegates. And the stage 2 and stage 3 will follow depending on what we plan and what kind of support we get. As far as procurement is concerned, the current procurement practices were as simple as we want to process 4 times the citizen applications per month than we are currently processing. So that is how a government tender typically lists an AI requirement for scaling. So we felt that there was a need for making procurement practices more detailed, more responsible, defining guidelines on what is responsible AI, how to judge it, how to test it, and how to deploy it. So I'll highlight, next slide, please. So the slides on the laptop are not changing.
No, but you can just ask on the slide. My colleague Janik is changing.
Okay. Okay, so 2023, we reviewed a whole spectrum of practices from all over the world, so India, South America, Europe, to find out what are the existing government practices in procurement. And we found that most of the practices are restricted to the aspect of procuring, but not the aspect of maintenance and deployment. So the report highlights the good practices of the world, but it also highlights the current gaps. And we look forward to having greater collaboration with governments in other parts of the world to actually implement some of these practices and see how AI procurement can happen in government departments, and how these practices play out in on the ground. And then we will publish these practices for wider availability. Juan, would you like to elaborate further?
Yes, thank you. Can we go back to the first slide? And yeah, that one. So just to wrap up what Aditya was mentioning, during the year we met with multiple stakeholders, including governments, academia, international organizations, non-profits, professional organizations, and companies who are interested in some sort of sandbox or at least testing bed for AI projects, and more specifically for public procurement. And so the report that will be published shortly includes resources along all the AI cycle of procurement. When I mean all the AI cycle is from the appraisal of a project that a government is foreseeing. We've understood after reviewing the literature and conducting these interviews with all these actors that so many governments are interested in acquiring AI, but they don't know where to start. And most of them should probably start with having people who are able to carry out the procurement processes. So that's why we started very early in the AI cycle. And the report covers the different stages until deployment. And we hope that this report will be a guide for practitioners and for government officials. It's still not a report about how to conduct the whole procurement process. That's something that may come up later on. This is just a review of all the tools that are available out there. Next slide, please. We do have some ideas of how this sandbox should look like. Should be experimental, agile, anticipatory, and collaborative with multiple stakeholders. And we say this because procurement processes require many eyes, require lots of hands, of course, and this may entail that the process is not fast, is not, let's say, sufficiently agile for the acquisition of technology. And this is why we have this basic template of principles that should, or probably should, guide the procurement process. Next slide. Oh, okay. No. So with that, I'll finish just by saying that we've learned a lot with the process. We started with an initial idea that Aditya mentioned, but during the process things changed. It was experimental in some way, and we hope to show you the report soon. Thank you.
Thank you very much, Juan and Aditya. And now I'd like to invite the next, if you move on to the next slide, I'd like to invite the three co-leads of the RAISE project, so the Responsible AI Strategy for the Environment, to present their project and objective. 7-8 minutes, guys. Good job. Thank you.
Yes. Hello again. While my colleagues are taking seats, actually standing up, as I see. Hello. So I'm co-leading this project with Nicola Mihaly and Lee Tidrich, who are on site. Responsible AI Strategy for the Environment. Next slide, please. So the objectives of so I remind you that this project has started in 2021, one. We started with one of the two projects, this one and the responsible and the social media project, which will come later. The objectives here are to develop and implement a responsible AI strategy for climate action and biodiversity preservation. So climate action and biodiversity preservation. We have produced foundational reports that you can find on our website, lay the ground for practical actions, and conducted applied projects also, standalone and use case, that's important. And we work also with international institutional partners to anchor AI for environment action. OECD, for example, was a very close partner with whom we worked on AI compute impacts, presented at COP27 and 26. So let's move to Nico and Lee for the detailed presentation of the project. Thank you.
Next slide, please. Yeah. Okay, carry on. Maybe just to begin, let me use the opportunity to thank Raja and Catherine for their leadership over the working group over the past years on that project and for their support. I want also to thank the Government of India, Bharat Sarkar, for hosting us so beautifully in that venue. Congratulations and thank you for your hospitality, and congratulate the incoming working group co-chairs, Francesca and Amir, and all my colleagues on the dais here for the wonderful work. When we started years ago, this intersection between climate, biodiversity preservation, and AI was not well understood, not well captured in terms of what can be done operationally. So a lot of what we've been doing is seeding the ground and community building, which people usually don't see a lot of value into. Why we're all congregating in that beautiful hall is to do that, to form a community. And exploring in a very practical way, but with that community building effort, the intersection between responsible AI and climate is something we've been doing for the past years. Combining, articulating, squaring up, as we say, the ecological and the AI revolution in the way that does not sacrifice but actually promotes the best from our values in terms of freedom, equality, respect for human beings, is the endeavor of a generation. We cannot miss this, and that's why we started with that project. As part of that, we've been working and will continue to work with so many organizations that you're seeing on that slides. People coming from the private sector, people coming from the activism and civil society sector, science, of course, economy, and obviously international organizations, the UN, of course. You cannot work on climate without the UN. Let that be clearly stated once again. And as part of that, colleagues from UNESCO, IPCC, and many others. This has happened. This will continue because this is one of the key value of that project, which is to seed the ground and form a community. Lee, do you want to elaborate on that?
Sure, we can go to the next slide. And just to pick up on what Nico and Raja said, and I will try in 2 minutes to summarize our work, you know, we really are at this critical moment that we can't miss. You know, we've seen the AI policy world take major leaps forward in the last couple months. In the United States, President Biden signed a really important executive order, and in that executive order, our president calls for attention on these AI and climate issues, and the political agreement that was reached in the EU in the last few days also underscores the importance of these issues. So what we've tried to do within RAISE, as Raja and Nico said, is create a roadmap to try to take these really important principles and reduce them to action. So we have our two baseline reports here, one focused on AI and climate, and as Nico said, we pull together the whole ecosystem. It takes a village to solve these really important problems, so we've had the pleasure of working with the OECD, with the UN, people throughout academia, throughout industry, and we've done a similar report on AI and biodiversity. And when we look at the impact, it's really twofold. It's looking at how can we use AI to help address the climate and the biodiversity crisis, but also looking at the flip side of it, that, and this has gotten a lot of attention recently with generative AI, that we have to make sure as we deploy AI, we are not exacerbating the crisis. There's been lots of press reports on how generative AI is consuming huge amounts of electricity and water, and the report that we had the honor of working on with the OECD last year and presented at COP27 really focuses on, you know, how do we prevent these adverse impacts. So some of the key themes that cut across both reports is, you know, we need access to more data. And that's where we work across different working groups, the responsible AI group, working with the data governance group, the innovation and commercialization working group, on how can we solve what we call the AI data challenge. We also need to create measurement techniques, which really came out in the report that we did with the OECD. We need to scale and build infrastructure. We have to make sure that we don't leave the global south behind as we do this, and some of the work has highlighted the impacts that this has had on the global south. So, a lot of work to be done, inspiring projects, and I'll turn it back to Nico to talk about our recent workshop and what we hope to do next.
Thank you, Lee. Maybe to elaborate on that in terms of the approach. We have tried to honor the communities that are behind these questions, the communities that are focusing on climate action, and the communities that are focusing on biodiversity preservation, first of all, separately. That's why we started with this climate and action report, table-setting report. I really encourage you and all governments representative in the room to go and check it out, read the recommendations, and we are willing to continue to work with you, as we have this year, to implement these recommendations. And then we did a similar exercise last year to initiate a conversation on the biodiversity side, because we realized that these two communities have obviously a lot in common, but not everything in common. And so honoring the challenges in a separate way to then try and reconcile that was going to be not a guarantee, but a better pathway to ensure that one is not crushed under the other. Communities in biodiversity preservation will often feel that climate goes first, and so it's important that as we look at these questions of preservation and conservation and the trade-offs that exist precisely at the intersection of these and AI, addressing them separately to then reconcile them. One other thing that we have and we will continue to do, and you can maybe move to the next slide, please, is to anchor this work and inform the work of science. And so we, this year at the workshop, to particularly try and take stock of what the revolution of large language models and general purpose AI systems mean for our work. I mean, there is a revolution going out there, the Gen AI revolution going out there. What does that mean in terms of opportunities and in terms of challenges for the intersection with the environment, and responsibly adopting these totally uninterpretable technologies, but powerful technologies, pervasive technologies, proliferative, some would say, technologies, in a way that serve what is the core of Sustainable Development Goals and what is the priority as we rediscover and rediscuss every year at the COPs. And one thing that became even more clear is that, well, AI indeed has tremendous, LLMs, so to speak, have tremendous potential to help better deliver on climate action and biodiversity preservation. Okay. But they can also, and they should also be used in an assessment manner. And so, can the work of the IPCC and IPBES on the biodiversity side be enriched by a solid, responsible AI adoption roadmap to enrich the scientific work that all these scientists do to model climate, to model biodiversity depletion, and find solutions? The response is yes, of course. And aren't there the best possible communities of practice to do that responsibly? Yes, it is. The scientific method is the pursuit of knowledge at this level of robustness demands certain ethical frameworks, demands certain practical framework. So yes, at this point of intersection, we can work and indeed build something which is responsible, and we are going to do just that. Another thing that emerged, and so we are going to try and continue to work and organize this trilateral workshop between GPAI, IPBES, and IPCC to chart together what a scientific roadmap for responsible AI adoption for climate action and biodiversity preservation could look like in the years to come. And another thing we're going to hopefully continue is continuing to work with our colleagues from the OECD, and particularly the AI and compute and climate task forces, try and work together, particularly now that the EU Act seems to be providing a new legal base to advance environmental actions and assessment. How can we move towards authoritative, independent, granular benchmarking protocols for the energy consumption and water consumption of these large language models? We need that. Our societies are demanding that we provide these tools, and I think we can play a role there. And maybe moving forward and closing with a bit of a vision in terms of what RAISE stands for. It stands, as I said, as a community building ground. The vision, the kind of flagship projects that we hope to be able to move towards with all of you in the coming years look like something like this. Do we need to be able to model planetary systems at a high level of granularity in the years to come to deliver on the ecological transition? Yes, and there are projects like that. Projects in the European Union, project probably here, new models. Do we need to do that in a way that we render these models, these large multimodal models, more interpretable? Right now, they are big black boxes. So for us as a community to try and break into these black boxes requires a vessel, requires a function that makes this an imperative and serves as to mobilize investment. So imagine a few years from now that we could all work and deliver on what could look like a CERN. For those of you who know the CERN, what is the CERN in Geneva? With the Large Hadron Collider, a CERN for AI in global climate action that would enable us to predict the climate not in the next 15 days, as we can do with weather forecasting, but actually climate model and environment modeling for the next 15 years at higher granularity. We cannot do that without a serious level of interpretability that could put interpretability and responsibility and robustness of these models, which are not robust when at the center, and serve as a coalition-building element to move collectively towards that goal. This is the kind of ambition that we require, that's the kind of institutional innovation that the world requires, without which I don't think we'll be able to durably combine AI and the environment in a way that really solves key challenges in a science-centric, science-driven, but if you allow me the expression, non-science hysteric way. Thank you very much.
Thank you very much to you both, and to Raja as well online. And now, the last but not the least, I'd like to invite Ali to present, then again, same challenge, not more than 8 minutes, the Responsible AI project for social media governance. Thanks, Ali.
Tēnā kātou katoa. Nō te heranga waka hau ko Ali taku ingoa. So I'll be talking about the work of the social media governance group. Next slide. And again. Oh, well, okay, looks something different on the screen. So yeah, social media platforms, by goodness, everyone uses them. Look at those numbers, 4.85 billion. I know that India is a big place, but 4.89 billion people use social media these days in the whole world. The average user, is this you guys? Do you use social media for 2.5 hours a day? I think yes, because look at you. You're all on your phones, and us as well on the panel, by God. It's happening, this is true, okay? So social media is a giant vector for AI use, and it's one of the main ways that we see AI in our daily lives. And there are 3 bits of AI I'm going to talk about, and they're all extremely interesting and need to be looked after and governed and overseen properly. And we'll talk about how we're doing that. So we're working on recommender algorithms and harmful content classifiers, and then the new generative AI tools, which are basically being used to disseminate AI content around the world. So different questions arise in oversight here for these different technologies, and that's an important idea, that you don't ask the same question for every different AI system. They're all different, and you need to think about them differently. For recommender systems, our main question is, what effects do they have on users? And in particular, do they have harmful effects that need to be known about so that they can be alleviated? For harmful content classifiers, the main question that we'd like to think about, and we're doing this in collaboration with colleagues in the room here in India, in a project in India, how should harmful content be defined, and crucially, methodologically, who decides what counts as harmful content? Is it the people behind the closed doors of the companies, or is it something else, or should it be something else? And finally, for generative AI, we're interested in this idea that AI-generated content is going to proliferate on social media, and what we need to do is to work out how to keep track of it. How do we know what is produced by machines and what's written by people? So I'll speak very briefly about all of those things. Next slide, please. But please come and talk to me afterwards. The first thing we did is work on recommender systems. So here, these are the systems, they're AI systems that basically monitor what you're doing as a social media user, watch what you're clicking on, basically, and then give you more of the same, right? Okay? So there's a problem with that kind of learning, which any AI person would know about. What happens is the recommender system learns from what you're clicking on, and then gives you stuff, and then you click on what it gives you. So there's a positive feedback loop, right? And that means that the learning of this system is unstable and might lead you in unexpected directions. And that problem by itself is quite serious, but there's worse given certain very well-documented cognitive biases that people have towards slightly strange content. They like to click on slightly unusual things. For instance, it's known in political discussions that people like to click on outrage, basically. Good Lord, this is a disgrace. Oh, I want to see more, I want to learn more. And if you go off in that direction and the system is learning what you click on, it's going to say, oh, this person likes outrageous stuff and being horrified, and it's going to give you more of that. Okay, but that's a danger, right? You can understand why that's a problem. Then there's this other one, very connected actually. So we also like to click on them, the others, the people from the other side. Oh, what are they doing now? Oh, goodness me. That's just a known, documented bias. But again, it might lead you off in strange directions. Finally, we like to click on false things more than true things. False things travel faster than true things. It's rather extraordinary, but it's true on the internet, and you know this. So the thing might learn that you like, oh, he likes that strange conspiracy theory, or they like this conspiracy. All of those things, we don't yet know how those affect public opinion. Clearly, they're having huge effects on public opinion. So AI systems, via these rather uncontrolled positive feedback loop learning processes, are having effects on the public opinion that we need to study better. And basically, we're working with the EU under the Digital Services Act, which is a piece of legislation which was only recently enacted, but it's now in force, which is going to give external stakeholders the ability to study these processes in more detail. Next slide, please. So here's another one, harmful content classifiers. Those are important and they're useful to help moderate content, and we need content moderation on social media platforms to keep platforms safe. But content moderation is also a trade-off with free speech, and so there's this very crucial question that needs to be resolved, this trade-off that needs to be finessed. Huge questions. And the point is that at the moment, we don't know very much about how content moderation happens. How do companies decide that this is content that's going to be removed? There's some information, but we need to know a lot more than we currently know. Basically, at the moment, they use content classifiers, which are, again, an AI system, but the way that they're trained happens behind closed doors. So our proposal is that the training sets for harmful content classifiers could be, instead of being assembled within companies, each individually to different companies, there could be a way of democratizing that process, and so it happens in a semi-public domain and consulting basically the public of users, So we're first of all thinking about training sets for harmful content classifiers in the domain of hate speech, and the idea there is just to directly consult citizens about what they think counts as hate speech and how it should be moderated. So for each item in this training set that we're imagining constructing, the idea is to gather the opinions of many citizens, maybe 100, maybe 1,000, maybe 10,000. Actually, this is an interesting new form of democracy, potentially. Democracy is a great place, a great thing. We're in the land of democracy here, the largest democracy. We're actually running a pilot of this particular proposal in India with colleagues that are in this room. We have Professor Sudhir Basu from Jadavpur University in Kolkata and Prabhata Rohan Chakraborty, who's from UCL and Oxford. And our chosen domain is political hate speech. And so we're interested in data sets that have been gathered, and this is work which my colleagues have done, in the lead up to recent elections. And the research question there is, can content moderation in this domain be devolved to essentially what counts as a citizen's jury? We're just interested to know if that will work. And we're running a pilot, and if you want to know more about that, we'll be talking about it on Thursday afternoon. You're most welcome to come along. Next slide. So finally, the last thing is AI-generated content. So this is to do with the generative AI powerful systems that have only been around for the last year, but that are revolutionizing everyone. So basically, there's a new authentication problem we're going to be faced with, a completely new one. When you see a piece of text as a consumer of text, or if you see a picture as a consumer of content, you have to ask yourself now, did a person do this, or did a machine make it? That has never happened before. It's a completely new problem, and we need new solutions to address this problem. So there are all sorts of reasons why we need to know. So we started off thinking about social media. In social media, we need to make sure and guard against AI-fueled disinformation campaigns. It's going to be very important for us to be able to have some way that social media companies can tell, like at scale, where large AI-generated political disinformation campaigns come from, and so on. But also, like, I'm a teacher in a university. I need to know whether my student actually wrote this thing. You know, I'd love to have some way of knowing, and it would be the same in any other professional context. So what's needed, we argue, is reliable ways of detecting AI-generated text. So we need a bit more AI to help keep the existing AI safe. So we know, you may know this, so current detection tools for AI-generated content don't really work, right? They're developed external to companies. They just don't work. Our suggestion is that the way to make them reliable is to place obligations on companies. And we have this proposed rule, which you can read about. We have a report at GPAI, and we've also written papers about this. Here's the rule. It's in yellow there. A company that produces an AI generation system must demonstrate and supply for free, actually, a reliable detection tool for the content that their system generates as a condition of that system's public release. And we think that interestingly pivots the way that companies have to sort of, they're now incentivized to spend effort and time, investment basically, in good, reliable detection tools. We've written 2 proposals, and again, we've had quite a lot of uptake with policymakers. Our proposal was adopted by the EU Parliament, and in its amendments to the AI Act, and we think that the recent trilogue, which has just concluded, we think that it's still in there. We can't say for sure. It's also been discussed by US policymakers. So as Lee was saying, President Biden has this executive order on AI, and a couple of the co-authors of our paper presented evidence at the judiciary hearing at the Senate that kind of fed into that process. And the executive order on AI also makes a lot of deal about this idea of AI content detection. So I think that's it for me, but keen to talk afterwards.
Thanks very much, Ali. Thanks actually very much to all the project colleagues for all the work and the efforts throughout the year. Very much appreciated. We're almost at the end of our session, but I'd like to pass the ball quickly to Raja Shatila, who had a few last words to share with the audience, and then I'll pass the ball to Amir and Francesca. So Raja, you're on.
Yes, thank you very much, Sophie. To conclude my role, I would like to heartfully thank our colleagues who have presented the group work, the projects during these years. And I would like also to extend my thanks to working group members, because with the colleagues, they were group members who contributed, experts to contribute to these projects, and also additional specialists who have helped us to build all these reports. Thank you all, and thank you for enthusiasm and this fantastic endeavor. I would like to also thank our partners, institutional partners, such as the OECD, and specifically. And now, in the name of Catherine and myself, after extending all this thank, I would like to pass the baton to our new co-chairs, the new group co-chairs, Francesca Rossi and Amir Bani Fatimi. Thank you all for attending, and thank you, Francesca and Amir, for keeping the work and developing it. Thank you.
Thank you, Raja.
Thank you very much, Raja and Catherine. I would want to warmly thank you for your all efforts for the past 3 years, but also not forgetting Yoshua Bengio that initiated this as well. Without your leadership, we don't have been here, but also all the members. We're happy to continue the work and share with you what we're about to do in the coming year. Can you show the next slide, please? If it's ready. The next slide, the other one slide. So the project that we're going to be working on in 2024, 4 of them are the continuity of what you've heard today, naming what Francesca and I talked about, scaling responsible AI, but also continue to work on systemic gender inclusion in AI ecosystems, naturally social media governance, as you heard right before myself. It's an important topic that needs to continue. The RAISE project and strategy for environment is critically important. We're going to continue that, but there is 2 new projects that basically after the sunsetting of pandemic resilience and regulatory sandboxes, 2 new projects are going to be starting. One is digital ecosystem that power committees. So as you heard about the pandemic resilience, there is a lot to do in terms of decision making and basically allowing communities to have a better understanding of how digital systems drive their life and how they can participate equally in the determination of decisions that needs to be made at different levels of society. So that's a project going to be unveiled to you shortly in the coming weeks. The other one is repository of public algorithms, which one is going to be leading, is basically arming and helping governments to create public repositories of transparent, trustworthy, reliable, responsible AI system and document them and to make sure that citizens can understand how these public algorithms are going driving their life. This is an important project as well. They're going to be part of that. All these 6 projects are going to be the bouquet and portfolio project we're going to be working on next year. And we try to make sense of them as a unison and make sure that all of them are supported not only through the work that we do here at this working group, but also in conjunction with other working groups. Can I pass on to the next slide, please? And before I pass, I think the slide before. It was not updated, so maybe you need to update that slide. So what Francesca and I want to share with you, and I'm going to pass on to Francesca soon, is that we try to coordinate all this work that we heard today in the Responsible AI group on 4 major axes. The first one is to work more with governments and partners to really understand what we're doing as a whole and to form more partnership and collaboration between different entities. The second one is to make sure that all the projects that are worked here on get more funding and more support to be deployed, because they need to be references, benchmarks, and model references that we can actually deploy. And some of the solutions need funding to get farther. I think the slide has not made it, so we're going to be talking about it. So the act that the direction we're working on is basically expand our relationship with other working groups within GPAI, but also more widely with governments and different organizations, industrial partners as well, to make sure that the work actually expands and makes sense, and specifically find support and funding for all this work to be deployed more widely. Francesca, would you like to add other potential points?
Yeah. So yes, we will work on those projects that Amir, listed and described, but we really want to increase the collaboration, and this has been done a lot already in this past year between members of GPAI, so governments, policymakers, and experts in both directions, like recommendations from experts and the projects, recommendation to policymakers, but also policymakers asking the experts what they need, what kind of help they need, what kind of project they need and work. As well as Amir said, to work also beyond GPAI. Of course, we have our standard institutional partners like the OECD, but there are many other initiatives that are all global and multi-stakeholder that address that have similar mission, but from different angles. So I think that we should work in a synergy and in a complementary way with these other initiatives so that we can all together, GPAI and all these other initiatives, really accelerate the path towards responsible AI solutions for all the stakeholders. So I really would like to finish thanking again Raja and Catherine and everybody, all the members for the amazing work that they did, all those work of this year and the previous years as well, but these years and all the reports. And we feel, Amir and I feel the responsibility of continuing on that great work. And of course, we will do our best, but we need the help of everybody here, the members, the member states, but also the member of the working group, and hopefully, collaboration with the other working groups. So I hope that, I'm looking forward really to work with everybody together. Thank you again.
Thank you. Thank you, Francesca. So we're both delighted to the next steps and the new journey for hopefully continuing the good work of Raja and Catherine.
Thank you very much to you both. Thanks to Catherine and Raja for their leadership in the past few years. We're at the end of our session. Unfortunately, we do not have time for questions, so I would like to invite you actually to just, when you get the occasion, if you have questions, just to speak with the different project colleagues during the lunch. They will be available today. So thank you very much to all for your attendance here in the room and online as well, and have a great summit, everyone.
We would also like to express our gratitude by presenting you a small token of appreciation from our end to all the speakers here. And thank you to all the speakers who have joined us online. Thank you everyone for joining us for this session today. Hope you all have a great day. We can offer the token of appreciation.
Picture. I'm sorry. Thank you.
Good. Thank you.
Thank you.
That was fun. So what do we need to do to be officially on?
Now we'll start playing.
नहीं होगा, it's fine.
Models are advanced AI systems designed to understand, generate, and interact with human language at an unprecedented scale. The launch of ChatGPT in November last year was a watershed moment in the evolution of artificial intelligence. Its ability to generate coherent and contextually relevant responses opened the doors to numerous applications, from customer service automation to aiding researchers in information synthesis. McKinsey estimates that the use of generative AI can add up to 4.4 trillion US dollars to the global economy every year. However, the development of large language models faces significant challenges in a multilingual world. While they excel in languages with extensive online resources, like English, they often fail in understanding and generating content in less represented languages. This limits the utility of LLMs in multilingual countries and raises concerns about linguistic and cultural biases. Today's discussion will aim to unpack these challenges and deliberate upon strategies to democratize language models. We are joined by a stellar panel of experts working on the cutting edge of this technology. I would now like to call upon the stage our panelists for today, Mr. Amitabh Nag, CEO of Digital India Bhashini Division. We have Professor Mohit Bansal, John R. and Louise S. Parker Professor, University of North Carolina. We have Professor Mitesh Khapra, Associate Professor, Department of Computer Science, IIT Madras. We have Mr. Americo Carvalho, Head of AI and ML at Amazon Web Services. We have Dr. Rohini Srivastava, Chief Technology Officer for India and South Asia, Microsoft. Dr. Vinod Kumar Prabhakaran, Staff Research Scientist and Lead Technology, AI, Society and Culture at Google Research. Mr. Manohar Paluri, Senior Director, AI at Meta. And Ankita Sharma, Segment Leader for Conversational AI, NVIDIA. So before we begin, I think we will get a group photo. Can you change the backdrop? And without further ado, I would like to request Mr. Amitabh Nag, CEO of Bhashini, to take over the proceedings. Sir.
Thank you. Thank you to everyone for being here, especially the panelists who are traveling across from, multiple locations to be here. And, there has been a lot of enthusiasm of LLM or large language models for last, so many months as we go by. And often it is talked about as what is good in language may not be good in knowledge, and what is good in knowledge may not be good in language. But LLM is all about good in language. And about the knowledge, there has been always a question marks which are raised. And often it is talked that it's a function of data and how well you train the child. The child is going to, grow up into a good adult or a bad adult or whatever. And so there is a lot of responsibility which the cohort here has who are interested in this particular topic. And we are here to discuss how do we create a large, scalable LLM, especially for the countries which are multilingual, and that is one of the aspects which is there. We also have the challenge of digital divide and literacy divide, and as you know, as Bhashini, we have been using voice as a medium to cover that up, and there are a lot of things which has been done by Bhashini, and Professor Mitesh has been a part of it to come over that multilinguality part of it, but still we have to do a lot more, and that is where we are sitting out here. Without further delay, I would like to invite Professor Mitesh Khapra to deliver the keynote address. He has been, working with the Project Bhashini for very long. He is heading the data management unit and has dabbled with these technologies. And I would like you to talk about it as well as the, how to tackle the multilinguality of it before we throw the session open for the other panelists to react to specific topics which we have. Professor Khapra.
Hi everyone. Thank you first of all for inviting me here, and a pleasure to talk here. So what I'll do is I'll give you some perspective on how Gen AI, at least in the context of LLMs, right, is very different from what it is in the English world, right? So first let me sort of introduce you to the English world, right, where all of us probably have played with this chat.openai.com, right? And of course, when it comes to the English world, I'm going to exaggerate a lot. And when it comes to the Indian situation, I'm going to underestimate a bit, right? So that gap becomes very clear. So when you talk about the English world, right, so what do these LLMs get powered by, right? They get powered by a large amount of text data available on the internet, right? And a few very simple statistics here. If you look at Wikipedia, there are order 6 million articles in English and order 1 lakh articles in Indian languages, right? So there's a huge gap there. And these Wikipedia, if you look at it as a repository of knowledge, there's a huge knowledge base available for English readily to feed to large language models, whereas for Indian languages, we are lacking behind, right? And it's not just that. If you look at any of the powerful open source LLMs which have declared the amount of training data that they use, they train on something known as 2 trillion tokens, right? In just plain words, it means that think a large piece of text which has 2 trillion words in it, right? And these 2 trillion words cover different domains like health, agriculture, politics, science, all of it, right? You can think of all the world knowledge is encoded in them, right? Now, if you look at Indian languages, there isn't so much data really available in Hindi, right? It's order billions of tokens and nowhere close to trillions of tokens, right? So this is one major difference from the English world, that you already had this data lying in. All you needed to do is build a technology like GPT-4. As I said, right, I'm exaggerating saying that all you needed to do, of course it's hard, of course it took time to get there, but then you could focus on that problem. You really did not have to worry about the data problem, right? And once you build this technology, you have a large number of users who are familiar with the English world, who have been using the English keyboard for ages. They don't have any problem. All of us, right? We just go and log into chat.openai.com and start typing in English. We have absolutely no problems in doing that, right? So users are already trained to explore English interfaces, right? They're already comfortable with English interfaces. And of course, there are a gazillion benchmarks which exist on which you could evaluate these large language models and say that, hey, on these tasks, now we are close to human performance. On these tasks, we are lacking behind. And these are a new set of innovative tasks that we have come up with, right? And a lot of new tasks got created once ChatGPT was exposed publicly to the world, where people started interacting with in various creative ways and say that this is the task I want, can you solve this, right? And all of this is now possible to evaluate in the English world, right? But now, if you come to the Indian world, right, how do you make this success happen in the Indian world? And that's a long journey. You can see that the slide is blank now, but don't worry, I'll fill it up. So you need a lot of tools for manual data collection, right? we, as a part of the Bhashini project, this is an ambitious project set up by the Ministry of Electronics and Information Technology. There is a huge plan to collect data for Indian languages across modalities, text and speech for now, and also a little bit of image data, right? But still a lot needs to be done, and once we scale this up, we'll have a lot of context from Indian public, right, which talks about their experiences, their folklores, their world knowledge, which can then be fed into large language models. Such a repository, knowledge repository of India does not really exist in digital form. All of us know there are many libraries in which data has been locked, right? It's available in textbook form or in the form of non-machine readable content. That needs to be unlocked, right? Imagine every library in India getting digitized to unlock all the ancient knowledge that we have in our knowledge system, right? So that effort is needed at scale. Almost think of it as a very large infrastructure which needs to be set up across the country. That is for manual data collection. There are also several sources of data readily available on the internet. There is web, no matter how small it may be for Indian languages, but we have not fully exploited it yet, right? We need to go and crawl all the content. The government again has done a fantastic job of having so many good websites on culture and Wikaspedia and other websites, right? But they are still not completely consumed and fed to these modern large language models, and we need to build the pipelines to feed them. Think of our own broadcast services, right? Like Prasar Bharati, All India Radio. All India Radio, every day, it has a broadcast, it broadcasts 3 bulletins every day in 40 plus languages, right? And these are news bulletins where a person is talking and the transcript is also available. Can we collect this for the past 20 years and feed it as Indian knowledge to these large language models, right? So many people now upload content on YouTube, our recipes, our take on Chandrayaan. The moment Chandrayaan was launched, if you go on YouTube, everybody in every language, there were thousands of people who wanted to say something about it, right? This is going from very laymanish, that we are very proud and so on, to very technical descriptions of what the mission involved, what was the team size, what were they doing, how did we succeed and so on, right? Can we capture all that knowledge by extracting data from these videos which lie on the internet, right? And similarly, a lot of data is logged in PDFs, which has a long legacy to it, right? Supreme Court judgments, for example, is one such database of Indian-specific content, and many other government websites have this. So can we create these data pipelines so that using all of this, we can build our Sangraha, which today does not exist. Sangraha, think of it as the knowledge repository which represent India, right? All our Indian knowledge system can be put into this one database, which can then be used to train a large language model, right? But unfortunately, even if we do all of this, the story still does not end there, and I'll tell you why, right? When an Indian user comes and interacts with LLMs, most of us will not type in our native languages. We can't type in Devanagari, we can't type in Tamil, we can't type in Telugu. We are used to the English keyboard and we prefer Romanized inputs. Unfortunate as it may be, many of us are not even very comfortable with spellings in our native languages. The difference between a Raswa E or a Dirgha Hi, the small vowel versus the bigger vowel, is often not clear to us, right? So we may just prefer to talk with the LLM in our voice because we can speak our language, no matter how imperfect it may be, but we can speak it. So just building an LLM is not enough. You have to focus on this more foundational technology of building speech recognition for Indian languages so that humans can interact with them. Similarly, you will have to build what are known as Romanized keyboards. The technical term for that is transliteration. That's what's written on the slide. Because we always, when we chat on WhatsApp and other places, we always type in Romanized context. Most of us type in Romanized. Although I'm talking in Hindi or typing in Hindi, I will not type Gh and R, I will type Ghar for Ghar, which is house in Hindi, right? So we need to have interfaces which can work with this Romanized content. Next, no matter how much data we collect, right, for the foreseeable future, a large amount of the world knowledge would still come from the English data, and it is possible that the LLMs that we build are better off in English than our own languages because the data is a bit skewed, right? I'm not saying that collect all the data which I've shown on the right-hand side, but throw away all the English world knowledge. No, you'll feed that too, right? And since that is still going to dominate, you might want to translate the input needs, the user's queries, and then interact with the LLM while also feed the original query that the user has provided, right? And before doing all this, of course, you need to build toxicity detection, right? That is one of the major challenges where LLMs get abused, and you need to do something about it in the Indian context. I think there's a question on that in the panel discussion, so I'll not go into more detail of now, but I have things to say about that. Now, similarly, once the answer comes back, you again need to synthesize that in Indian languages and optionally also translate before synthesizing it, right? So it's not just about building LLMs in India, it's like starting ground up, where you collect a lot of data for all this foundational technology, collect a lot of data for the modern LLM world, synthesize all these technologies together into one system which can work seamlessly in a multilingual context, understands multiple languages, can speak in multiple languages, can translate, can look up the LLM for reasoning and so on. Right? So this entire picture needs to be created, and that is definitely much more complex than the small picture that you see on the right hand, on the left hand side at the top, right? So all of this needs to be done in a multilingual country like India, and efforts like Bhashini and others would really go a long way in enabling this, right? So I'll end my talk here, and of course I'll join the panel for more discussion. Thank you.
Thank you, Professor Mitesh. And data is one of the important aspects of LLM. But just taking the topic, slightly away, and talking to you, Professor, Mohit Bansal, it's about, there are a lot of research works which are going on in this area, and being part of many of them. Would like to know what are the various avenues of AI, research in AI, research in LLM, and research in NLP technologies which are available, which were going to impact all this which we are talking about the diversity, about the cultural biases, about various type of data, etc., etc. So, if you could throw your light on that.
Hello, can you? Okay. Yeah, thanks. Thanks for the great question, and thanks, Mitesh, for a nice summary of the challenges and the opportunities that lie ahead. So I'll keep it brief because we have a lot of questions and a lot of great panelists. So, so in terms of opportunities or things that AI, we are already seeing very good use cases for, right? I'm sure you've seen a lot of things around you, all the way from better chatbots, right, for even things like personalized customer service. There's a lot of impact already in things like education, right? The dream for a lot of people, including, for example, Sal Khan from the Khan Academy, is about personalized tutoring, right? One-on-one tutors for kids. There's a lot of work that's been done for things like getting into healthcare, molecule drug discovery, right? Automatic drug discovery, finding relations between different kinds of drugs and molecules. So it's an endless road to opportunity. But like you said, at the same time, there's a lot of challenges as well as risks that we need to be aware of. So in terms of missing data, right, that's one probably big topic for today. What could we do? What are the challenges as well as opportunities? I think basically there's a lot of opportunity in multimodality, personally, right? If we can connect multilinguality to multimodality, and by that I mean you could use images, videos, documents, right, which Mitesh also referred to as other modalities, right? Because as humans also, right, we use a lot of our joint senses when we are using these modalities as bridges, right, between languages. It can give you some extra context, right, that may not be either available, or sometimes it's actually not supposed to be available, because some things are better said in language, some things are better seen visually, right? So different modalities have different purposes. So that would be one thought that we can expand on later. And also I feel like culturally, right, since you brought up this question very importantly, cultural biases, I think again, the other modalities could help you sort of resolve certain biases that only one modality might have, right? Because you can actually figure out that, wait, I misunderstood this sort of cultural bias here, whereas when I have another modality like an image, I was able to actually correct my bias. So we've been focusing a lot on unified models, which means basically they work with audio, text, vision, like images, videos, documents, right? All of these together as a unified input and output paradigm, where you can basically combine any kind of inputs and try to generate any kinds of outputs together, such that there's three advantages, right? Shared knowledge between these modalities, a general architecture, right, instead of specialized architectures, which is very infeasible, right, resource-wise. And third of all, it's also very efficient. You can actually get n times less parameters, right? But the same number of capabilities. And then on the risk side, we'll probably cover a lot of this today, is about the data should also not be coming with its own bias, right? So there's missing data, but sometimes if you get tempted and use the wrong data, right, then it can insert a lot of biases into your models. So there's a lot of obviously work there on first having the data itself be clean and representing diverse opinions, which is very, very hard to scale. So then should we do that as a sort of automated way or semi-automated way, or could we do it in a post-processing way where can we edit the model and remove certain biases without retraining the model? So there's a lot of work going on now on model editing. Can we figure out where the biases are stored in the model, which is very challenging. But even when you figure it out where it's stored, it's not easy to actually edit or delete the knowledge based on that localized information. So I'll probably pause here and then.
Yeah, just one supplementary question to that. There's a lot of debate about one large language model versus narrow models. What's your view on that, and where is the research going in that?
So I was actually just answering this exact question at the NLP conference that we just came from. So my opinion here is that it should not be one large monolithic model. When I say unified, it's more about having modules, right? So you basically should have a library. Think of it as a library of skills, right? Even when we code, right, we import different kinds of libraries. So I imagine it as having modules or libraries for different kinds of skills where different LLMs already exist, right? There might be a very strong state-of-the-art LLM for video and language. There might be one for multiple languages, right? Maybe 30 languages that can be handled together. Then someone else makes a language model for another set of 25 languages, right? But they don't overlap. So these would be modules, and then the language model's job should be able to program or plan over these modules and figure out for a new unseen task, which could be a new translation task or a new video to, say, text translation task, right? Language to language translation, image to language translation. It should be able to figure out which modules should I use from my library and in which order should I combine them. And then maybe there'll be a last challenging step where sometimes none of these modules are enough. That's where another power of the LLM should come in to decide which module should I grow and expand, right, to bring in these new capabilities. So that's sort of the final challenge of unseen generalization or compositional generalization. So my opinion is that it should be a skill of libraries or modules where we can take all the state-of-the-art LLMs that already exist, right, and we keep adding to that library when things keep getting better in terms of state-of-the-art, and we don't basically use it as a monolithic structure, but try to learn combinations over these.
Yeah, thank you. Thank you. I think, some deep thought views around it, and, we will, perhaps the other panelists can also, give a view around it once their chance comes. But I'll just move on to another question, and perhaps, Rohini, this is directed to you, is that, there is, you people have been in the thick of the innovation which has happened and the challenges which has happened around that innovation. So how is this, give a view on how is this shaping for the industry? What are the various use cases you see? Does the negative thoughts which are around this, how are you guardrailing them? And how do you, taking this business forward so that, people are able to know how good or bad this technology is?
So let me start by first pointing out that the large language models, which we call, at least the one that is called the generative pre-trained transformer, the model, it's the paradigm shift is important to understand. What I mean by that is the way in which previously machine learning models used to work, that you would train a model for a specific task, let's say for language translation or for face recognition. You would use that model for that particular task. You did not use that model for other tasks, or you do not expect the model to work for other tasks. The paradigm shift that has happened with these LLMs is that these have become foundational models. What that means is they are able to perform tasks beyond what they were trained for. That paradigm shift changes a few things. First, it changes that you don't always, in fact, you are not encouraged to use its internal knowledge representation. What you do is you actually have an orchestration layer on top of the model, which brings in knowledge from domains, gives it to the model to reason and create output in natural language. Let me give an example. If any of you have used Bing Chat, which is a search engine, and it's a chat on top, what is it doing? When you ask Bing Chat, what is the weather like today in Delhi? It is not asking the large language model what is the weather in Delhi. The large language model has no idea. What it is doing is, it is throwing a query to a search engine which has information about weather in Delhi as of today. It is orchestrating that information to give to the large language model that is then able to respond to you in natural language. So that fundamental shift of how you use these large language models is an important one to grasp, because then you start to think about how are you going to use it for different use cases. Now, the places, to answer your question, Amitabh, the places we are seeing this is in this whole area of augmentation. And by that, I use the term co-pilot. Let me give an example. If, let's say, you are trying to do, you're trying to write something that is a new essay or something, your ability to give the context to the model, let's say you're writing on, I don't know, Indian handlooms, your ability to pick Indian handloom information that the model doesn't know. Don't expect the model to know about Indian handlooms. That is the paradigm shift. You take information about Indian handlooms, you give to the model, that's the orchestration layer. Then you work with the model to create something for you that is in natural language. So if I go into different use cases, for example, today if you are using Air India and you're trying to book your reservations using Air India, its chatbot, it's using OpenAI underneath. How is it doing that? It is not, the OpenAI chatbot, OpenAI model doesn't understand what Air India does, but it has context, the grounding is given based on Air India's latest offerings, what are the schedule changes, what are the options. That is then given to the large language model to then provide a natural interface to the customer. This you can now replicate across industry use cases. Look at, for example, hospitality, look at Make My Trip, look at travel industry. Any of these industries, in fact, today you have an ability to create a chatbot for your website literally in one click, because its ability to ground the data based on the website and be able to ask questions. So I think that paradigm shift is important to understand. And I'll end with the point. I think I first of all love what Mitesh was talking about in terms of the Indic language corpus of data. I think that is very, very important. But it's also important to realize, to the point I'm making earlier, is that the way today you use these large language models, and of course we should create one. Of course it is important to make sure that India's knowledge language is incorporated into something that is going to be considered as intelligence, right? That is superbly important. I totally understand that. But today, if you were to say, if you follow my point about the paradigm shift, and you are very familiar with the Bhashini world, how did the Jugalbandi chatbot work? What the Jugalbandi chatbot is doing is that it is using the PM Kisan Yojana corpus that is given to the OpenAI model. The OpenAI model doesn't understand what PM Kisan Yojana does. But your ability to query the context, by giving the context of PM Kisan Yojana to the OpenAI model and query it using Bhashini as language, is then allows the model to give you information that is grounded on data. That's the paradigm shift I wanted to call out in terms of our understanding how this is different from machine learning of the past decades.
Right. Thank you very much, Rohini. And, you know, obviously we are seeing a lot of use cases which are, you know, bringing up inclusive society, because you are now able to query using the natural language and are able to find a lot of things. America, you have been involved in a lot of, you know, machine learning, you know, research, otherwise also. What do you think the world of NLP is, which way the world of NLP is going in the world of this large language models, you know? Will there be more solutions which we will found? How will this impact, the large language model research or the usage, or it will aid to it? And what are the different solutions which you see coming up in the future?
Sure.
excited to be here. Thanks for the opportunity.
Yes, thank you. Yes, so first, super excited to be here today, and thank you for the opportunity. I'd like to come back just a bit on the comments that have been done by the two professors here as well, in terms of the challenges for the Indian languages. We do recognize, and that's something that we observed across the board, and again, my view is much more practical, observing how public sector customers are right now interacting with generative AI and dealing with the large language models. So the question of language is something very common in Europe, for instance, which have a lot of fragmented languages. There is also this Chinchilla law, which basically states that for one parameter, you need roughly 20 tokens to train the model. So that really gives us a sense of the magnitude of the data that is required if we want to train just 100 billion parameter models. On what has been commented also on the, what's the future, what's the use cases look like, and how many large language models are we going to use, either a big one versus a multiple LLMs. We do see the trend with our customers that even for very basic use cases, they recognize that there are hundreds of different LLMs of different size, of different skills, and even a very simple use case can very likely articulate many of those LLMs. Because of course, depending on the use case, depending on the step of the use case, you don't necessarily need the same skills. You don't need the same size of model. When we talk about large, very large models, for instance, they also come with a cost. This cost could be in terms of a latency or just the cost that basically the model provider is charging for the usage. So back to your question now, what we are seeing across the board in public sector is definitively more than just new technologies, keeping humans in the loop to help adding skills to those models in terms of different types of languages. It's also more and more leveraging the opportunity to use continuous fine-tuning and continuous training, even for the large language models that have been pre-trained on very large data sets. They need to stay connected with the actuality and reflect that to the use case. So when you start combining human in the loop and those kind of technologies, that really starts giving you an edge on how you could tackle adding additional languages to those LLMs.
Thank you. One of the things which have been talked about, and this perhaps I would direct it to Dr. Vinod, is, since broadly the open source has been a buzzword, and you guys have been quite working on the open source part of it, how does this approach help, and does it help in the LLM world? How does it foster collaboration? What have been your experiences around it? So it's a question of the approach which, overall building a scalable, LLM people should take.
Thanks for the question. And I'm happy to be here, and thanks for the invitation as well. So, before I get to the open source question, I think I want to start by sort of like acknowledging like the capabilities that have just sort of like these new recent technologies, like recent advancements in LLM technologies have like enabled us to do. And in doing that, like the open source kind of ecosystem provides a way to sort of accelerate that in scope and in impact in a multitude of ways. And when I think about open source, especially in these kind of technologies. Large language models, I think of them as like a dual-use technologies, like that they can have like potential kind of misuse and malicious use cases. And this comes from the fact that like I work in a responsible AI organization, and I think about those aspects of like sort of side effects or things that we don't really foresee. And those issues become like a lot more challenging in an open source setting. So I personally do not have like a strong opinion of like in favor or against open source, but I do recognize that it is very it does accelerates the scope and impact like very quickly. But I'll stop by also saying like a few words about the responsibility angle, because like that's important even when you because whether Google or other any particular entity decides to open source their models or not, and there are definitely going to be open source models that are out there, and they are improving in their performance like by the week. This morning I saw a new open source model has come out, which has like kind of like matched the GPT 3.5 performance, I believe, in whatever benchmarks they were talking about. But in all those contexts, I think the responsibility aspects of this is like super important, and that there are challenges around the data that like folks talked about, but also model interventions, and like there's a lot the open source community can do in there, because individual companies or entities may not be able to sort of like completely solve these problems, because especially from a responsible AI standpoint, a lot of these are social or societal kind of knowledge that is important to intervene there, and you'll need like a larger sort of a collective effort to intervene there. I don't know if open source, the way we conceive it right now, is necessarily the framework that would be the most effective and safe way of doing it because of the concerns that I mentioned. But I think of it more as community engagement. There are other avenues of community engagement that can address some of the gaps in data, address some of the gaps in societal knowledge that will be important to sort of expand these technologies' scope and capabilities in a safe and responsible way.
Thank you. I think, yes, responsible and ethics become very important for that, and that brings me to the next question, Manohar, if you could help me around it. It's, regulation, ethics have, been under discussion for LLM for quite a long time. Long time means ever since last few months, and it has been long enough because there has been a lot of discussions around it. So what are your views on that? How regulated it should be? What way in which we can, leave it for ethics to be followed, a self-regulatory mechanism? What are your views on that, and how will it, increase proliferation of LLM, or, for example, stop the proliferation of LLM as it goes by? So, people are today hesitant to use it, but some people want to use it because there is a technology which is available, and it should be used, right?
Yeah, thank you for having me here, and I think it's a great question. I like to think of past examples rather than trying to reinvent the wheel. So if you look at what Meta has done historically, all the way going to open compute, which is the hardware revolution of building the most efficient data centers, that wouldn't be possible if it was taken as an initiative by one company. If you think about the ecosystem that we evolved in machine learning with PyTorch, that wouldn't be possible if it was one company pushing the PyTorch ecosystem, all the way from hardware integrations to software optimizations to developer ecosystem, and what new kernels need to be there, what additional software packages need to be there to proliferate machine learning. So if you look at what we did with Llama, and specifically Llama 2, the fundamental responsibility that we feel is to accelerate the field while making sure we are doing it in an open way and making sure it's a multi-stakeholder, multi-party input that goes into testing these models, looking at the emerging capabilities, having a tremendous amount of impact for the world across all countries and all cultures, figuring out where things don't work, listening to the input, and making sure as a community we are pushing the capabilities forward. I don't think you can do it as one company. I don't think you can set rules as one company. I think you have to do this by bringing along everybody, by showing what works, what doesn't, by actually setting a strong benchmark of best practices, a strong benchmark of safety suites. If you look at the 70-page Llama 2 paper that we wrote, a significant part of the content is actually focused on responsibility and safety. The innovation that we have done in making sure the model is not just helpful, which is how we think of assistants today powered by these large language models, but also how they can be safe. What are the things we need to do on the pre-training data? What are the things we need to do on post-training and fine-tuning and alignment? What are the things we cannot do because we don't know how to do because it's an open research problem? And making sure that efforts like Purple Llama that we just announced is basically a combination of attackers trying to see how the models perform, what are the pitfalls, what additional measures we can do to mitigate them. So that's really how we think about the responsible angle of this, is like bringing along all of these stakeholders, making sure that the know-how is common across all of the folks in the companies, in the startup ecosystem, as well as governments and so on, and evolving it's a cutting-edge technology. Like somebody was talking about a new model that came up this morning, I was not surprised. There was a new model last week, there'll be a new model tomorrow. In that world, we want to make sure we are iterating quickly together.
Thank you. Ankita, coming to the question of, which is basic underlying factor of large language models is compute. And we all know it is a significant part. That's perhaps one of the things which actually, sometimes it is called a roadblock to, whether you can build a large language model or not. So what could be the new innovations and how innovatively we can tackle this problem? Everybody talks about having a very large compute and then going for a large language model, and sometimes then figuring out the use cases. All of that is some of the things which have been under discussion. So would be very keen to know your views on that.
Yeah, thank you. Thank you so much, Amit. It's a great privilege to be here, and it's been really great hearing your partners' insights. Before I get to the computational heft question, I do want to address one issue in developing countries where text data is limited, and I think that was highlighted. And so what is actually required is a multilingual speech and translation AI software for building and deploying fully customizable, real-time conversational AI, including automatic speech recognition, text-to-speech, neural machine translation application that can be deployed in cloud, data center, at the edge, or on embedded devices. So that's going to be super critical wherever text data is limited, because all the models are as good as the data that's available to them. We at NVIDIA here always lead with the use case. And one of the use cases that my personal focus is contact center transformation. And contact center transformation across the globe for various industry verticals like retail, healthcare, telecom, financial services, and insurance. So starting with the use case is the right approach. That's what I would say. Now, going back to the question of computational heft for scaling with large language model, whether you are doing a research or you are an enterprise ready to deploy generative AI in production, you need to start with an innovative platform like NVIDIA AI Enterprise. NVIDIA AI Enterprise is not just end-to-end platform for deploying production-grade enterprise ready generative AI solution, but it's a lifeline of generative AI. It includes an AI software framework called NVIDIA NeMo, which really optimizes the training time and the resources that are required. So making it lean and less demanding on the precious available resources. At the foundation of NVIDIA AI Enterprise is an accelerated computing infrastructure. The accelerated computing infrastructure, you guys, is pivotal. Why? Because when our customers deploy it, they see the cost falling compared to it being prohibitive in the past. That's transformational, right? Because especially in developing countries, the financial resources can be scarce. So that's transformational. Then finally, the cherry on the top is the cloud-native software tools. These cloud-native software tools really make it easy to deploy. They simplify the deployment, opening up the doors and widening the access to AI. So that's another advantage of it. Now, I want to take a case as an example of a recent announcement that was done of TensorRT LLM inferencing speedup of 6.7x on H200 GPU on actually Llama 2 70B and the world's largest model called Falcon 180B. What we were able to show to the world was that what took 8 GPUs in the past, you can do that in one GPU, one single GPU. And that was all because of the TensorRT LLM inferencing speedup that an accelerated computing infrastructure can provide. But what's personally very meaningful to me as I work for this company is how NVIDIA is committed towards empowerment and education. It's all about making sure that developing countries are not just joining in, they are driving the AI revolution. It's all about making sure that we are nurturing the local expertise and making sure that they're not just participants, but the AI leaders and innovators. And that's the empowerment of NVIDIA AI Enterprise. And it's a powerful step towards making sure that our AI future is inclusive.
Thank you. So coming to Professor Mitesh, you know, India is a country, and we heard all the panelists about, you know, different things, different points about a large language model. And India is a very diverse linguistic country, right? And preserving this diversity was one of the propositions through which why Bhashini is there as a project as well. So what do you think, you know, India's strategy should be from a perspective of building a large language model and keeping the multilinguality aspect of it, you know, preserve the multilinguality aspect of it, and also go to multiple other activities which are...
Yeah, I think I'm audible. Yeah. Yeah, so now if you think of this Indic LLMs, right? Now, what do you mean by Indic LLMs, right? So I think they mean 3 things. Of Indian use cases, LLMs of Indian use cases, LLMs for Indian use cases, LLMs of Indian languages and Indian content, right? So technically it's a language model of something. So current LLMs are language models of English predominantly. We want language models of Indian languages and Indian content, and LLMs by Indians, right? And there's a lot of fanfare around this LLMs by Indian where statements get made, various controversial statements get made, and we pay a lot of attention to that. But in my view, we should focus on the first 2 also, which is LLMs for Indian use cases and LLMs of Indian languages, right? So let me talk about LLMs for Indian use cases. I think Rohini already touched upon that. Even today, it is possible to build something like a PM Kisan bot for a farmer who only speaks Tamil using all the open source technology that is available out there, right? You could use all the open source models that are available on Bhashini to act as language interface, the speech recognition, translation, speech synthesis, all of this you can use. And in middle, you could put any of your powerful open source LLMs like a Llama 2. And I'm focusing on Llama open source because I think in the government setup that is important, right? So Llama 2 is one, Mistral is another. Any of these permissible licensed models, you could integrate all of this together and make something like a Jugalbandi, which we have seen, or any of these government chatbots, or making people aware of schemes, something as simple as calling women who are pregnant and reminding them of the different medications and different checkups that need to be done, right? All of this is possible even today by integrating the language technology that we already have, right? So this is LLMs for Indian use cases, and this is where we should all put in a lot more energy and get more things running on the ground, because once that happens, And once people realize what we can do with this language technology, with this entire ecosystem of language technology, just the LLM just being in the middle, there'll be more interest in the other two, which is LLMs of Indian languages. Because now we'll start realizing, hey, this does well, but when I ask it a question about the Kanda Poha ceremony, I don't know how many of you know about it, it's a ceremony in Maharashtra where the prospective bridegroom meets the prospective bride for the first time, right? And what is served is Kanda Poha, that's why it's called Kanda Poha ceremony. Now the GPTs of the world will not have this context, right? Because there's no Wikipedia page on this. There might not be blogs written on this. But I'm sure there are people who have written about this, have shared their experiences about that in the regional language. So that is what I mean by LLMs of Indian languages and Indian contexts, right? Indian content. And that is where we need to invest in the middle term, where we take a powerful LLM and teach it more about India instead of thinking about building LLMs from scratch, right? So that they get more aware of the Indian context, Indian content, Indian languages. Today, one problem with GPT-4 and many of the other models, including Llama 2, is that suppose you ask it to answer in Hindi. It produces very good answers. I'm talking about GPT-4. But what you need to realize, the right technical detail there is, if for you and me that answer is 100 tokens or 100 words, in GPT-4's interpretation, it is close to 1,000 tokens, because GPT-4 almost treats every Indian character as one token, right? And why is this important? This is important because we pay per token or pay per word of output getting generated, right? So if you're generating a 100-word output, which is reasonable, you asked it to write one paragraph on the Battle of Panipat, 100 words is reasonable, but you will pay for something like 1,000 tokens because it has not seen enough Indian language tokens in its pre-training data. The tokenizer does not have enough Indian language content. So that's why I mean by of Indian languages and of Indian content, where we feed in Indian data in Indian languages, so the native capacity of the LLM in these languages becomes better, as opposed to sort of taking the English route, or as opposed to treating them as languages which just have character level tokens, right? And both of these are important. So that's what we need to invest in the middle term, take the best open source model and add Indian language data to it and continually pre-train it. In the long term, what comes is LLMs by Indians, right? And once we have enough experience in the first two, we'll be able to talk about building LLMs from scratch in India by learning what are the applications that we really want to focus on. If I want to build an LLM, and the largest application that I have today is agriculture and health, I better have a strategy that I feed in a lot of data from Indian knowledge systems on agriculture and medicine into this LLM, right? Right now, just going out and blending in the blind, just collecting random news data from the web and trying to build an Indian LLM does not really cut it. It's too easy, too early to rush in to do that, right? And not just that, right? It's not just about building the models, but it's also about aligning the models, what you know as supervised fine-tuning. So the base LLM knows world knowledge, but then it has to be made better on certain tasks. What are the tasks that we care about? Do we care about tasks in agriculture, healthcare, STEM, education? If those are the tasks, then invest in collecting data for those languages. Ask Indians to collect data for those languages as opposed to taking data from the West and translating it, right? So that is again LLMs by Indians, where we create our data, we decide what are the applications that are important, we build our models, and then align the models to our ethos and our culture and our preferences, right? Right now, the models are basically aligned to data collected in the West. Can we align them to Indian preferences? Then I'll give you an example, right? If it's a formal context, I would prefer AAP. If it's an informal context, I'm okay with 2. This preference has to be taught to the model that if you're referring to Mahatma Gandhi, you have to say Mahatma Gandhi ji and unhone as opposed to usne, right? Which is not very respectful. This alignment to Indian culture is something that we Indians will be able to do, but that's in the long term, right? So again, summarizing, the short term is for Indian use cases, the mid term is of Indian languages and Indian content, and the long term is by Indians starting from scratch and thinking about things that we care about and build LLMs for those.
Thank you. Three-step approach, actually. Professor Mohit, you know, coming back and you heard all the panelists talk about it and the Indian context as such. What do you think the 3 areas of research which India should carry out towards the building scalable LLMs?
Yeah, I think I agree with a lot of what Mitesh said. I think, except maybe the third bullet, right? It maybe it's not feasible or necessary, right, for every sort of group of users to build their own LLM, and then I'm focusing on the term from scratch, because I think we should be, like I said before, using a lot of resources already available to us. There's millions of dollars and 100 crores of rupees that might have been spent right very soon on different kinds of LLMs that already exist. And so my firm belief is being able to extract more emergent and unseen behavior from these language models, and you'll be surprised how it's not that hard to be able to make them do very different things. I'll give you an example. We had a recent work showing how you can take GPT-4 or any sort of strong, and we showed open source versions too, language models to create plans for long distance multi-scene video generation. Right, so that was basically not foreseeable beforehand, because these models have not been trained on anything related to long multi-scene videos, but they have a lot of capabilities like being able to do co-reference resolution between scenes, right, and understanding which pronouns and nouns and entities refer to each other. Or they also understand things like prepositions, right, that if something is on top of the other, a cat is on top of a bed, then the bounding box or the segmentation for the cat, when it's generating that frame, right, should be higher in Y coordinate than the bounding box of the bed. So we can use a lot of, this is for multimodal, right? Now for languages, we have a lot of power in joint representation spaces, right? So if we have built a large-scale language model which is already learning a joint space across several languages, it's very good at finding nearest neighbors, it's very good. And so like I said before, right, maybe we should be able to first see whether there's a multitask setting where it can understand a new scenario of a new language by combining existing sibling languages and neighbor languages right through the language tree, family tree. Or it could also go into the continual learning setup instead of multitask learning, where you actually keep giving it a little bit more data, but minimally, right, to be able to make it learn a new skill. And both of these, I think one thing that we haven't covered so far in the panel is the factor of efficiency. So we should not be trying to scale things unnecessarily, right? We should be actually forcing them to be as small as possible so that they could also run live on every villager's maybe 2,000 rupee cell phone, right? Which has minimal memory, minimal storage, and minimal sort of flops, which is the speed, right? So there's a lot of focus in the community on how we can basically do continual learning, multitask learning by very efficient methods like model merging or adapters or LoRa or quantized LoRa, sparsified quantized LoRa, right? Where the idea is that you try to insert very specific minimal modules into these models and only update those parameters to teach it new skills or new languages. Or you can basically try to merge vectors of existing tasks in a way that they can actually not lose their skills that they had learned previously, right, when they were trained from scratch, while also being good on new skills.
Right. I think a lot of insights there. Americo, what would be your thought on this? You heard us speak about a lot about India. I don't know how familiar you are with India, but multilingual. There is a digital divide, there is a literacy divide, yet we are looking at using technology for the benefit of the common man, the last mile. So what would be your thought and your takes on that?
Yes, so totally aligned with what Professor just mentioned. I'll add on this idea to make sure that we reuse what has already been created and try to be very lean. Making sure that we can operate in the cloud is inherently something that helps with a lot of considerations. Just prior to this session, we had a session that was tackling, for instance, the correlation between AI and the environment. And so indeed, kind of building an infrastructure just to train a model, it's like building a dam just to handle a spike of energy. I'll come back. I'd like to come back a bit on the cost. We mentioned cost a few times. I believe this is something that is super essential, critical right now. When we look at the way AWS customers are using their generative AI projects, they all started exploring, and all the solutions that have been described using proprietary models, using open source models, they work, they produce outcomes. Now it's very difficult to find outcomes that are economically viable. Customers are really struggling, making sure that the return investment, the cost just to inference with those models compensate the optimization, the operational efficiency that they are looking for. So I think those are the two dimensions that by the next months, the next year, I expect that the market and the community is also help to tackle.
Thank you, thank you. I think that's important. Yeah, you were wanting to say something.
Yeah, I wanted to plug for 2 points, right? One, if you go look at multilinguality, I think we should not underestimate the progress we made in translation. So, and I'm saying this because we tested Llama 2 outputs, which are predominantly, obviously a significant amount of tokens are English, but it has multilingual tokens. So what we did is, so we have this model called NLLB, No Language Left Behind, which we trained on 200 input and 200 output, of which 25 languages are actually Indian. This is text only. We were able to use that translation system for continued pre-training as well as fine-tuning on top of translation outputs. You take English fine-tuning data and you translate it using this translation model, and you train the original Llama model, and it does a really good job on these new languages. I don't want to discard low-hanging fruit efforts like those. And this is not just on text. We also talked about seamless models on speech, which actually support real-time translation of various languages. So that is ASR now that you can do, and TTS. So I do think there is an opportunity there, and people should experiment a little bit more, because translation has been something that has been worked for decades. So that's number one. Second, on inference cost, I think it's important to contextualize where we started. So if you look at where deep learning was with AlexNet model in 2012, it's a joke in terms of the capacity of that model now on where we can, how much compute we need to do inference with AlexNet model. That's 10 years. I know it's a long time, but given the acceleration of the field, I don't think it's unimaginable to see in a couple of years where the cost of many of these models go from these 7 billion high-capacity models to distilled versions, which could be in the order of 100 million model or 1 billion parameter model, where the cost significantly comes down, specifically when you start special purposing many of these models. I think this is a real test for our field, where one part of the field will push for this universality, generalization, because we want to go after AGI, general intelligence. And then this other part of making it work for specific use cases with the lowest amount of cost and efficiency in mind. And I think that duality is great for the field.
Yeah, that duality is great. And Rohini, you are doing many things in this field already, you know. So what are your views, and how do we actually, you know, make the needle move as far as India is concerned?
So couple of observations. One, I think in the long term, I really do appreciate what Mitesh was saying, because I think it's a question of, if one is looking at whether you want to call it AGI or anything, if you're looking at AI having knowledge, intelligence of humanity, it's important that India's knowledge and wisdom and history is well captured in there. So that's a very high level comment, but I think to me that's important. But having said that, I think there is a lot of work that can happen in the near term in terms of bringing the benefits to people, whether it's education, healthcare, the patient-doctor ratio, the teacher capability, etc. There's tremendous opportunities to leverage this technology to bring benefits to the common person, along with Bhashini, along with the work on Jugalbandi, Bhashadan, many of these things that we are working on. So that's one. I think the overarching point that Amitabh you talked about is the issue of emerging countries and very diverse, very culturally complex countries like India. I think that area is an active area of research at Microsoft. In fact, there is a project that's a multi-stakeholder project called VELLM, called Universal Empowerment with LLMs. It's actually evaluating every single model out there in terms of its accuracy, applicability, universality for multiple tasks, complex tasks, simple tasks. So there is a lot of active research happening in that space, and I expect my research colleagues, and I'm sure some of them are working with Mitesh and some of the folks here, to continue on that. But I think an immediate output, like I said, we have to keep the long term in mind while we keep making some real impact on the ground in the short term. So one of the outputs from that work is being piloted right now, called Shiksha Co-Pilot. It is being piloted in a few schools in Karnataka, wherein the co-pilot, which is think of it as an agent that's able to help teachers from middle school to create engaging, interesting lesson plans, for example, for their students based on the actual syllabus corpus, being able to create experiments, homeworks, etc. So really be a teacher's co-pilot to help them be more effective in their classroom. And that's one of the, I think of it as a short-term impact, while the longer-term thinking about how to make sure that the LLMs really are there for universal empowerment is an ongoing project.
Right. Ankita, coming to you, we talked about, going to the last mile, and Professor Mohit also talked about having efficiency on the last mile. What are the possibilities of GPU miniaturization to actually reach the last mile devices which are being used, maybe the smartphones and feature phones?
As it relates to LLMs?
Yeah.
Yeah, so, I will take an example of conversational AI pipelines. So we have, I talked about this, that we have an AI framework called NVIDIA Riva, which is a GPU-accelerated multilingual speech and translation AI for building fully customizable real-time conversational AI pipeline. And that software is actually available to be deployed on embedded devices. So scalability is super important. Efficiency is super important. And also making sure that we can deploy it, whether it's in cloud, whether it's in data center, whether it's at the edge or on embedded devices, is going to be super critical, especially in developing countries, where, like I mentioned, the financial resources can be scarce. So having that adaptability is super critical in order to scale. Did that answer your question?
Yeah, that's
okay,
some way, yes. But yeah, it was a quite futuristic question also. That's fine. Vinod, coming to you, when we are talking about India, multilinguality, ethics, responsible AI as such, what's your thought process on, how should India proceed when we are trying to build up a LLM or, adopt a LLM, or the step-by-step approach which Mitesh talked about? What are the boundaries, guardrails which we should be drawing upon?
Yeah, thanks for that question. I think, we talked in the panel, we talked about various kind of gaps that needs to be filled in terms of equitable sort of capabilities in like different languages, about sort of access to technologies like the digital divide and the literacy divide that you talked about earlier, as well as like various sort of fairness, bias issues that these large language models often have, like that may propagate sort of societal biases that are existing in the data sets. For instance, like in one of the recent work that we analyzed, like some of the large language models to actually tell a story or write a story about like a girl going to Paris versus a girl going to Ghana in Accra in Ghana. And like the story of the girl in Paris is about like, oh, going to museums and like, arts, culture, all sorts of things. Whereas like the girl, I think it was a boy, was like playing some sports in like a dirty sort of playground, and then like an American kind of non-profit person came and like gave him education, like gave him money to go get education. That was a story that was sort of like that the LLM decided to tell. And this shows like the deep sort of like biases, societal biases that are reflected in the data sets that are being captured as knowledge. It is some sort of social knowledge, but that's not the knowledge that we necessarily want to propagate. And so when we talk about like responsibility, often people don't go beyond like defining what that means, and often it ends up being talking about safety in a sort of like offensive language kind of context, which is also a very challenging problem. But there's all these other aspects of responsibility that should be looked into. And to solve that, like the way I think about it is, or people that I work with, our team think about it, is to sort of not think about it just in terms of multilingual technologies, but rather multicultural technologies. It's not just a matter of throwing a lot of like data in a new language into like these models and like sort of figure out that it would just like learn to sort of like engage in that like cultural ecosystem. You need to take into account the larger cultural ecosystem within which those language communities operate, the cultural knowledge that is needed to operate that, and also the cultural values and norms that we incorporate into these models. And in terms of the approaches or avenues of sort of intervention there, I think there's a lot of avenues are in terms of data. Like we talked about it, so I wouldn't go into much detail, but I do want to make the distinction between training data, which is what a lot of us talked about, but also evaluation data, which is like super important in this context. And evaluation data means that you have to sort of like build evaluation, not just in terms of capabilities of certain tasks, but also like the sort of responsibility or fairness, social sort of like tasks, like or sort of like how much these biases are propagated and so on. For that, you need like societal knowledge like on various socio-cultural contexts. And there are various approaches that you can do, and our team has been working on like building, even in partnership with LLMs, like you can use these large language models to build those broad coverage resources that can then be used to evaluate these models. Because like the way of like building evaluation data by just like hiring like a dozen annotators and like human annotators like would be the answer. Those days have passed, I guess, because each human annotator or each human labeler brings a lot of sociocultural sort of knowledge into their like into their labels. So whenever large language models, any model capability, people talk about it in terms of, oh, we have matched like human capabilities or human performance. I'm like, which human are you talking about? Like humans are not interchangeable. So building evaluation resources that are multicultural, that have multicultural representation is also important. And yeah, I'll wrap up there. So there's like, and in doing that, so they're like LLM based, or like you can do it with in partnership with LLMs to like have better coverage for this societal knowledge, but of course with like social validation, socially situated validation, but also community engagement. Like we recently have a paper actually tomorrow. Day after tomorrow, I'll be presenting it at NeurIPS if I get there, which is where we built a data set of social stereotypes that exist in India through a community-centered collection of like from hundreds of people from various 8 or 9 universities across India to build that resource, rather than just like recruiting like say a few human annotators to do that. I'll stop there. Thanks for the question.
Thanks for that insight. Just I would like to wrap this session up by, inviting one-liner comment if you have to take, and I know it's difficult, but if you have to choose one such parameter, like what should be the core of building large language model is, if I can start off with you, Mitesh.
One-word answer, data.
Trust.
Do it in the cloud.
Said one sentence, I think making it work for the world.
You caught that. being globally responsible.
I think you said one line, didn't you? So generative AI is not a buzzword, you guys. It's real. And if you sit this one out, you're going to fall way behind in the market with respect to cost and innovation. So let's do this.
I think, just very strong optimism with just very strong carefulness, right, about things like responsibility, bias, and then the other thing I would repeat is efficiency, all kinds of efficiency, data efficiency, parameter efficiency. That's the way to make it accessible to everyone.
Right. I think, the last round of, one word or one sentence covers it all, and it, gives you insight that we need data, we need trust, we need to be responsible, we can't be left behind, we need to be efficient, and of course we need to be on a scalable infrastructure like cloud, which is there, and of course be responsible about it. So, gives you a summary of what we are. Thank you very much, all of you, for making the time out for today, and also giving us this insight. It has been wonderful discussing this topic with you. Thank you.
Thank you.
We could just stay on for some time.
Yeah, we have some souvenirs as a token of our appreciation for your time and effort. So I would request Amitabh sir to please hand it over to our panelists.
Thanks a lot. Nice meeting you too. Thank you so much. Well, you're really spoiling us here with gifts. Yeah, it's like Christmas.
Okay, sir.
Let's stay on for that one.